Hello there, and welcome to Sleepy Cosmic Podcast, where we wander beneath velvet skies, following ancient light on its unhurried path through time. If this kind of quiet wonder helps you rest, I'd be grateful if you tap like or subscribe. No pressure at all. Wherever you are tonight, whether in a city of faint streetlights or a quiet countryside field, thank you for sharing a few calm minutes with the stars. Now, dim the lights, maybe turn on a fan for a soft background hum, and let's ease into tonight's journey together. The story begins far away, beneath the thin blush of the Martian sky. The Perseverance rover, parked on the ochre plains of Jezero Crater, was meant to study rocks and dust, not mysteries. Its cameras, built to hunt traces of ancient rivers, were instead watching the sky on the 4th of October 2025. On that day, something unexpected drifted across its field of view, a soft, elongated glow, pale and unwavering, moving where no satellite or moon should be. It wasn't bright enough to cast a shadow on the ground, yet it lingered, like a faint brushstroke of white across the salmon-coloured horizon. The rover's navigation cameras, or navcams, recorded a sequence meant for calibration. But when scientists back on Earth reviewed the data, they paused. The image didn't show a star. It wasn't a streak of cosmic dust or a glitch. It was an object, glowing softly in the cold Martian dusk. They compared frames, stacked exposures, and ran noise reduction algorithms. The result was consistent. A thin, elongated line of light, about 4 times longer than it was wide, crossing the sky at an angle that didn't match any known spacecraft or natural debris. And at its edges, just barely, there was a tint of green. That was enough to ignite curiosity across multiple continents. Astronomers recognized the date because only days earlier, orbital tracking systems had predicted a rare visitor passing near Mars, a newly detected interstellar object known as 3I Atlas. 3I for the third interstellar visitor ever confirmed, and Atlas for the Hawaiian Survey telescope that first caught it glinting against the void. Interstellar objects are more than astronomical curiosities. They are messengers from outside the solar family, pieces of some other star's story crossing into ours. The first was Oumuamua in 2017, tumbling silently through sunlight, its shape still debated. The second, Borisov, in 2019, looked more like a conventional comet. But this third one, 3I Atlas, was different even before Mars glimpsed it. As data came in from ground-based telescopes, its motion was fast, faster than any bound comet should be, moving at 67 kilometers per second relative to the Sun. That speed guaranteed it could never stay, never loop back, never be trapped. It was just passing through. Yet the brief alignment with Mars offered a chance never seen before. The first interstellar object observed from another planet's surface. We often imagine cosmic exploration as cleanly planned, mission scheduled, instruments ready, data flowing. But the universe doesn't wait for readiness. It moves on its own schedule, and sometimes, like a whisper through static, it delivers something surprising. The images sent from Mars arrived at mission control during one of Earth's quietest weekends. Staff were minimal. Analysts logged the files for later review. It wasn't until the next day that an engineer noticed the anomaly. He thought it might be lens flare, maybe sunlight scattering through fine Martian dust. But the dust was calm that day. The rover's logs showed no motion, no camera shake, no software errors. The streak was clean, symmetrical, and bright against a still background. Out of curiosity, they compared the sighting time with predicted trajectories from the minor planet center. The numbers aligned within minutes. 3 Atlas had been passing directly above Perseverance's field of view at that exact moment. It was, in a way, an unintentional miracle. Billions of dollars in robotics and decades of planning had placed a machine on another planet, and by coincidence, or perhaps inevitability, it happened to look up just when something from another star drifted by. When we think of Mars, we picture isolation, a silent world, a desert of iron oxide dust beneath an alien sun. But that day, it became a point of connection. For a few seconds, two wanderers met, one built by human hands, the other forged in a distant system millions of years ago. Scientists soon realized the implications. They had, for the first time, an observation of an interstellar object from beyond Earth's sky glow and atmosphere. No clouds, no atmospheric scattering, no interference, a direct planetary vantage point. Even if the image was faint, it carried enormous value. It meant we were no longer just observers from one world, we were now watching the galaxy from two. But with discovery came confusion. The shape seemed too stretched, the brightness too stable. Most comets, when photographed under long exposure, revealed diffused comas, rounded envelopes of dust and gas. This, however, looked like a thin sliver of solid light, a shard suspended. The greenish tint was faint but undeniable, especially when viewed through wavelength filters calibrated for iron and nickel reflection. Somewhere in those frames, there was a whisper of structure, something not entirely random, and though scientists were cautious, others, those who linger at the edge of speculation, began to murmur. It's in our nature to look for meaning in shapes, to connect lights in the sky into constellations, to imagine purpose in motion. But still, the pattern of that glow felt deliberate, as if the object's shape itself was directing the light rather than scattering it. Maybe a trick of perspective, maybe something more. Mars, with its thin air and silent plains, watched and said nothing. The rover went back to work, turning its cameras toward the red ground. The object slipped away, shrinking into the direction of the sun. Yet its trail of data remained, numbers, pixel values, photon counts, and those numbers would soon ripple across observatories on Earth. In the calm halls of mission centers, scientists compared notes and data streams, an unexpected detection, a rare alignment, and above all, an unanswered question. What exactly did Mars see? As night settles around us, imagine standing on that distant plain beside the rover. The sky is pink near the horizon, fading into purple overhead. Thin winds brush the dust into spirals. There, above the stillness, a pale streak glides silently across the void. It could be a rock, it could be a message, it could simply be light, stretched by distance and time. Whatever it was, for one brief moment, Mars looked up and saw something from another star. For days after the rover's images reached Earth, astronomers quietly checked, recalculated, and whispered to each other across time zones. The confirmation came gently, with little ceremony. The object Perseverance had seen was indeed 3I Atlas, the third confirmed interstellar visitor in human history. The designation carried meaning: 3I for the third interstellar, Atlas for the telescope survey that first glimpsed its motion among background stars in late August. Yet what truly mattered was what it represented. Across the universe, fragments are always breaking away, icy crusts torn from newborn worlds, metallic shards flung out by supernovae, dust and stone wandering for millions of years until, by impossible luck, they pass through another star's domain. When 3I Atlas was detected, its path already told part of its story. It came in from the outer dark, travelling on a hyperbolic trajectory, meaning it was not bound by the sun's gravity. Its velocity, 67 kilometers per second relative to the sun, was too high for capture. It was a transient, here only briefly, before it slipped back into interstellar space. But the timing was remarkable. The alignment with Mars, the angle of approach, even the brightness visible from Jezero crater, all of it fit within a narrow window of coincidence. It was as if the object had chosen its path carefully, though reason tells us nature doesn't choose. Nature simply follows its laws, and sometimes those laws lead to near miracles. In astronomy, coincidences are sacred things. they remind us how much of discovery depends not on control, but on patience. The comet Borisov, the second interstellar object, had entered the solar system on a path almost aligned with the galactic plane. Oumuamua before it had arrived from a completely different direction, spinning like a baton through space. Each visitor had been unique, each rewriting what we thought interstellar debris should look like. Throughout Atlas, however, felt different from the start. Not only because of its brightness, but because of its relationship with Mars. For a moment, it came close enough that human machines, sitting on the surface of another planet, could actually look up and record its passage. That alone made history. It meant the interstellar frontier was no longer something observed only from Earth. It had crossed the border into our multi-planet reach. The images released from Perseverance showed faint detail, but they were enough to give scientists a starting point. The light curve plotted over several frames revealed a smooth brightness. No flickering, no tumbling pattern that would suggest chaotic rotation. That steadiness was strange. Most comets spin irregularly. They wobble, flash, and dim as their bright sides turn toward the sun. This one seemed poised, as if rotating in a controlled way, or presenting the same reflective surface throughout its observation window. Back on Earth, telescopes tracked it as it moved through the constellations of Pisces and Aquarius. It shone faintly green, with a surrounding coma, an envelope of gas and dust driven off by solar heating. Spectroscopic readings showed unexpected ratios of gases, not much water vapour, but strong carbon dioxide signals and a peculiar enhancement of nickel lines. Astronomers at the European Southern Observatory's Very Large Telescope began monitoring the emission spectra night after night, noting changes. They saw the nickel abundance increasing faster than models could explain. No one quite knew why. Normally, when a comet approaches the Sun, its sublimation rate, how much material it loses, follows a predictable power law: double the sunlight, and it releases roughly double the gas. But for 3I Atlas, the numbers climbed far more sharply, like something was being activated instead of melted. Meanwhile, the James Webb Space Telescope aimed its instruments at the comet's coma. From 1 million miles beyond Earth, Webb detected signatures of carbon dioxide that accounted for nearly 90% of the gas, a staggering ratio. For comparison, typical solar system comets show maybe 10 or 20% carbon dioxide, the rest being mostly water vapour and other volatiles. Webb's findings made 3I Atlas chemically alien. The Mars image now gained new meaning. Perhaps the glow Perseverance saw wasn't just reflected sunlight, but outgassing, jets of material streaming away, producing a faint luminescence even at great distance. Yet that alone couldn't explain the elongated shape. A coma's light tends to be round, diffused, fading evenly into space. The rover's photo, by contrast, displayed a structured sliver. As the data circulated, institutions across the world began crafting press releases, each cautiously worded. Preliminary indications suggest an interstellar object, one said. Confirmation pending further analysis. Another emphasized that the elongation could be a result of image stacking during long exposure. But no one could ignore the curiosity the image inspired. For a few days, social media lit up with the discovery. Amateur astronomers posted their own frames, blurry but enthusiastic, of the faint green smudge moving against starfields. News outlets called it the ghost above Mars. People wondered aloud what it might mean to witness something from another star crossing the sky of another world. Beyond the fascination, a quieter excitement filled the scientific community. For decades, astronomers had theorized that interstellar objects must be common, millions passing unseen through the solar system every year, yet their small size and dim light made them nearly invisible. To find one at all was improbable. To capture one on another planet's camera felt like a reward for persistence. Still, some were wary of overinterpretation. Space exploration teaches humility. Data, especially at the edge of detection, can deceive. Cosmic rays, camera artifacts and exposure streaks often imitate real objects. The line between discovery and illusion is thin, but this time, calculations confirmed it. The timing, the position, the trajectory, all matched 3I Atlas. It's remarkable how something so distant, moving faster than any probe humanity has built, can trigger such quiet wonder. A single elongated glow on a dusty red planet seen by a robot reminded us that the universe doesn't revolve around our presence. It keeps sending travellers our way, fragments of elsewhere. Some just happen to cross our gaze. Imagine standing beside Perseverance as it looked up that day. The sky is thin and silent. The sun is small but dazzling, half the brightness of what we see from Earth. The light stretches across red sand, and for a heartbeat, something gleams above, long, white, unhurried. It drifts on, leaving no sound, no trace, no trail of smoke. The moment passes, but the image remains, and through it we remember that even on worlds we haven't set foot upon, our eyes, mechanical though they are, still catch light that began its journey around another sun. The first detailed analyses of Perseverance's images began to arrive in October's second week. Teams at the Jet Propulsion Laboratory and European Space Agency processed the raw navcam frames, correcting for pixel noise, adjusting contrast, subtracting background stars. What remained, after calibration, was something that refused to disappear. A thin stripe of light cut across the Martian sky, slanted like a falling beam, bright at the centre and slightly tinted green at the edges. It wasn't a random scatter or an artifact that vanished when filters changed. It was persistent, consistent, and measurable. The object had a discernible width-to-length ratio, about 1:4. That ratio would soon become the foundation of debate. At first, many dismissed it as the product of image stacking, a common method to amplify faint details by layering multiple exposures. When objects move quickly during stacking, they appear elongated, smeared by time. A bright star, if stacked improperly, can stretch into a band of light. So, some argued, 3I Atlas was merely moving too fast for Perseverance's settings. Nothing more mysterious than that. But when independent researchers ran simulations using the rover's exposure time and known motion speed of the object, 67 kilometers per second relative to the Sun, the expected blur was not nearly enough to account for the observed shape. The streak should have been fainter, more tapered, more evenly coloured. The real image looked different. Bright white in the middle, clean boundaries, and a greenish haze only at the outer rims. The green was subtle, visible only after wavelength isolation, yet its presence mattered. In space imaging, colour isn't decoration, it's chemistry. A green hue can indicate gases like cyanogen or diatomic carbon fluorescing under solar radiation. On Mars, where the atmosphere is thin, such emissions would appear unfiltered, pure. The fact that the colour appeared symmetrically around the white core suggested a structured source, not a random smear. The analysts checked for internal reflections within the camera lens assembly, light bouncing off sensor layers, sometimes creating phantom shapes. But those ghosts tend to repeat, and the navcams were designed with baffling to prevent exactly that. No matching reflection pattern was found. The stripe's alignment matched the expected vector of 3I Atlas's trajectory. Every cross-check returned the same quiet answer. It wasn't an illusion. From there, the image gained weight. Scientists began treating it as a legitimate observation rather than a glitch. The long streak wasn't just light stretched in time, it could be light stretched in form, an elongated object reflecting sunlight from its own geometry. To most, this seemed improbable, but not impossible. The solar system is filled with oddly shaped relics. Comet 67P, with its duck-like twin lobes, asteroid Cleopatra, shaped like a giant dog bone, and Arakoth, a snowman-like contact binary frozen at the edge of the Kuiper belt. Nature does a symmetry well, yet 3I Atlas's proportions were extreme, even compared to those. The first interstellar object, Oumuamua, was estimated to be between 100 and 400 meters long, but only about a tenth as wide, giving it a cigar-like aspect ratio. 3I Atlas appeared several kilometers wide by comparison, possibly 20 kilometers across its longest dimension. The scale dwarfed every known interstellar visitor. That alone justified the growing unease in research circles. As we drift through this mystery, it's worth remembering how fragile the process of seeing truly is. Every image from another planet is the result of alignment, time, motion, angle, software. A fraction of a degree, a fraction of a second, and the truth can warp. Yet the human instinct is to look closer, to trust our eyes, and then question them endlessly. When the Perseverance team released a public frame, muted and faint but unmistakable, the internet did what it always does. Theories bloomed like frost crystals. Some claim the green hue hinted at propulsion, others at plasma reflection. Many compared it immediately to Oumuamua, suggesting perhaps we had just seen another artifact of interstellar engineering. Most scientists brushed off such notions, at least publicly. Space is full of strangeness without intent. Still, something about the image felt deliberate. It had a clarity that accidental blurs rarely possess. The edges were too clean, the symmetry too calm. In the silence that followed, professionals quietly reached out to amateur astrophotographers, hoping for independent confirmation. On Earth, the comet had been tracked for weeks. Some long exposure images taken through narrowband filters showed hints of elongation even from ground-based telescopes. Nothing as distinct as the Mars image, but suggestive. If you were to stand beside Perseverance in those minutes and look up, your human eyes might not have seen the object at all. It was too faint, the sunlight too harsh. But the rover's cameras, sensitive to wavelengths we can't perceive, caught what we could not. A whisper of structure within motion, a memory of light. In the laboratories of Cambridge, Caltech and Beijing, teams overlaid brightness curves and analysed gradients pixel by pixel. They found the core brightness stable across frames, implying that the white centre wasn't a transient flare. It maintained its luminosity as it crossed the sensor's field. That steadiness contradicted the random streak hypothesis, and so the debate quietly shifted. If the image wasn't a blur, then the elongation might be real. And if it was real, what could it mean? Could a natural body stretch to such proportions without breaking apart under rotation? Could it maintain structural cohesion if composed of fragile ice or porous rock? On Earth, long before we had telescopes, sailors mistook meteors for omens and comets for messengers of fate. The same instinct lingers in our language. We still call them visitors, wanderers, heralds. We speak of their arrivals and departures as if they intend them. Yet even in that superstition lies something poetic, a recognition that sometimes the universe sends reminders of its own vastness. 3I Atlas was one of those reminders. It came from nowhere we could name and moved toward nowhere we could follow. And yet, for a brief instant, it painted a perfect line of light in another world sky, a single brush stroke across the silence of Mars. In the end, maybe the mystery isn't whether the shape was real, but that it was seen at all. Across the gulf of planets, a machine we built lifted its gaze and caught the light of something older than our species, older than our sun. That moment of alignment, the seeing and the being seen, was itself a kind of miracle. When the image was released, one of the first to comment publicly was Professor Avi Loeb from Harvard. His tone, as always, was careful, neither dismissive nor sensational. Loeb had become a familiar figure in discussions of interstellar visitors. His earlier writings about Oumuamua had made him both celebrated and controversial. This time he approached the Mars photo with the same calm skepticism. He proposed that the elongation seen above Mars might not reflect the object's true shape at all. Instead, he suggested it could simply be an artifact of motion. When a fast-moving object crosses a sensor during a long exposure, the camera records a trail, not a snapshot. The faster the movement, the longer the trail. Combine multiple exposures through stacking, and the apparent length stretches even further. To Loeb, the streak's geometry was consistent with this explanation. At 67 km per second relative to the Sun, 3I Atlas was moving across the Martian sky roughly 1/10 of a degree per second, enough to create a blurred trace in the navcam's imaging sequence. The green at the edges, he argued, could be chromatic dispersion, where different wavelengths of light bend or overlap slightly during processing. His reasoning was sound, rooted in basic optics. Yet, as others soon pointed out, it didn't fit perfectly. Dr. Horace Drew, a retired molecular biologist turned image analyst, was one of the first to push back. Drew had studied spectral interference patterns in scientific imaging and noticed something inconsistent: the white center. If the green hue represented coma emissions, gas glowing around the nucleus, then motion blur should have diffused the green more evenly, softening the edges. Instead, the green appeared confined to thin borders, while the central region remained bright white, suggesting that the white portion itself was the main emitter or reflector, not merely the camera's average of brightness. If Loeb's theory were correct, Drew said, the streak should fade smoothly from white to green outward. But the actual colour separation was abrupt, symmetrical, and persistent across multiple stacked frames. That pattern, he argued, implied that 3I Atlas possessed a solid reflective body, white in tone, surrounded by a faint, possibly ionized green halo. It wasn't proof of anything artificial, but it wasn't a simple motion artifact either. Something about the physics of the image remained unexplained. The debate played out not in heated press conferences, but in quiet email exchanges, private Zoom discussions, and a few cryptic posts on research forums. Scientists by nature prefer caution. It's easier to explain a blur than to accept a mystery. Yet sometimes the data doesn't settle where comfort lies. Meanwhile, on the other side of the Atlantic, at the European Space Astronomy Centre, technicians were reviewing their own datasets from Mars orbit. The ESA's Trace Gas Orbiter, equipped with the CASIS camera, had also attempted to image 3I Atlas during its flyby. The resulting frames were faint, grainy, and incomplete, barely distinguishable against the background noise. They showed what appeared to be a point-like light with a surrounding haze, but no elongation. ESA's official statement was cautious. A faint, comet-like object was detected approximately 30 million kilometers from Mars, consistent with the trajectory of 3I Atlas. Its coma is visible, though the nucleus remains unresolved. The words unresolved and beyond camera design limits quietly acknowledged that the images offered little more than confirmation that something was there. Still, the timing of the ESA release was peculiar. The images appeared 4 days after the initial detection, 4 days during which every other space agency remained silent. NASA's press offices, usually quick to clarify or contextualize high-profile discoveries, issued no comment. China's Tianwen-1 orbiter, which had a perfect vantage point, released nothing. The Hope orbiter from the United Arab Emirates, designed for Mars atmospheric studies, also stayed quiet. A silence that broad, across rival nations, rarely happens by accident. Publicly, NASA attributed its delay to the government shutdown that had begun on October the 1st. The agency was operating in minimal mode, with most public affairs personnel furloughed. That explanation satisfied casual observers, but professionals found it thin. A shutdown pauses outreach, not science. Data still flows, missions still operate, and other nations, unaffected by US politics, had no such excuse. The thought lingered. Perhaps the agencies were waiting to verify, to coordinate, or simply to agree on what story to tell. Within astronomy circles, the debate over the image's authenticity became a kind of mirror for larger questions. How do we interpret something rare? When the line between instrument error and revelation is so delicate, how do we balance skepticism with wonder without losing either? Loeb himself seemed to sense that duality. In a brief interview, he acknowledged the limitations of every camera, every instrument, every theory. All we can do, he said, is test hypotheses against the data we have. But even when we can't explain what we see, we must remember, the unknown is not the untrue. His words resonated beyond academia. They carried the same humility that drives much of space science. The willingness to remain uncertain, to say, we don't know, not as defeat, but as invitation. For those of us listening from afar, it's easy to imagine these arguments as tension or competition, but in truth, they are collaboration in disguise. Each challenge sharpens the other's view. Loeb's caution keeps speculation grounded. Drew's curiosity keeps questions alive. Between them lies the path toward understanding. In the quiet background of these discussions, the object itself kept moving. 3 Atlas continued its journey crossing the orbit of Earth, unseen except through instruments. Every day it drifted closer to the Sun, and with each 1,000,000 kilometers, its activity grew. Its green glow brightened. Its spectral lines deepened. Somewhere between the cautious mathematicians and the dreamers, between Harvard and amateur stargazers, between the dust of Mars and the telescopes of Earth, the truth about 3I Atlas hovered like the object itself, elongated, bright, and just beyond reach. When we look back on these moments someday, perhaps we'll smile at how primitive our instruments were, how faint the data, how endless our speculation. Or perhaps we'll remember them as the first steps toward realizing that not every traveller between the stars is made entirely of ice and rock. Some might carry stories we aren't yet able to read. For now, all we have is that white core, those green edges, and the quiet debate between those who say it's just a blur, and those who whisper that maybe, just maybe, it isn't. The argument over the photograph's colour balance might have remained an academic curiosity if not for one small stubborn detail, the green. That hue, soft and faint yet persistent, was what astronomers called non-random. It appeared in separate images, across different calibrations, and even faintly in ESA's later release. To dismiss it as artifact meant ignoring that pattern. Dr. Horace Drew focused on it relentlessly. He wrote in one technical commentary that, if the Perseverance photo truly represented a moving object blurred by motion, then the colour distribution should smear along the same direction as the motion itself. But in the Mars image, the green lay across the edges of the white core, not along it. The distinction was subtle, but important. It implied the colour belonged to the object, not the camera. He described it poetically, a white heart wrapped in a green breath. To him, that meant 3 Atlas was radiating from a structured surface, perhaps crystalline, perhaps metallic, and surrounded by a thin envelope of gas fluorescing under ultraviolet light. Most astronomers still lean toward natural explanations. Comets, after all, can display strange hues. The familiar emerald glow of some comets comes from diatomic carbon molecules breaking apart in sunlight, a process known as photodissociation. These molecules exist only briefly, a few hundred kilometers above a comet's surface before they are destroyed by radiation. Their green light is the echo of fragile chemistry at work in vacuum, but that typical green comes from the gas, not the solid body. In 3I Atlas, the brightness reversed that order. The solid centre dominated the light, and the gas seemed secondary. It was like a glowing pebble wearing a faint veil, not a gas cloud hiding a dim nucleus. When Drew published a colour-corrected composite using Mars's atmospheric baseline as reference, The core stood out starkly white, with a spectral slope similar to silicate minerals or perhaps polished ice. The halo, by contrast, resembled emission lines of cyanogen, CN, around 388 nanometers, a wavelength easily excited by solar ultraviolet. That combination, white silicate-like reflection and cyanogen fluorescence, was extraordinarily rare. Even comets rich in cyanogen typically show a dusty beige nucleus. Something about 3I Atlas seemed cleaner, almost engineered in its simplicity of tones. Still, Drew's analysis was speculative. He had no access to the raw telemetry or the rover's original sensor calibration tables. The mainstream journals declined to publish, citing lack of verifiable data. Yet among observers online, his images spread rapidly. Amateur astrophotographers enhanced them further, and what emerged looked almost geometric. A white spindle, surrounded by faint green mist. People began comparing it to Oumuamua, whose brightness variations once led some to propose a reflective, perhaps artificial surface. Loeb himself had suggested that Oumuamua might have been a light sail, an object propelled not by rockets but by sunlight pressure. Though he had become more cautious since then, the parallels were impossible to ignore. If the elongation seen above Mars was genuine, then 3I Atlas was even more extreme, a shape potentially tens of kilometers long, gleaming white, shedding gases that glowed unnaturally green. And so the question shifted from what it was to why it looked that way. From a purely natural perspective, an elongated comet can result from tidal stresses, when a fragment breaks off a larger body and stretches under rotation. Over millions of years, collisions can grind it into a spindle, the same way river stones become smooth. Some theorize that 3I Atlas might be the remnant core of a disrupted exoplanet, ejected from its system long ago. Others wondered whether the unusual ratio of carbon dioxide to water, observed later by the James Webb Space Telescope, might hold the key. If most of the ices were carbon dioxide rather than water, the surface would reflect light differently, producing that dazzling white core when sunlight struck it directly. Still, the green remained unexplained. Cyanogen alone couldn't account for its intensity given the object's distance. Something was amplifying it, perhaps the same process driving the object's steep rise in outgassing as it neared the sun. At night, astronomers stared at their screens, watching plots of spectral intensity. The numbers climbed with an elegance that bordered on eerie. They followed a power law of roughly 9, a steepness rarely seen in comet physics. Normally, gas production increases roughly as the square or cube of solar flux. This one surged exponentially, as though triggered by a threshold event. Some joke that it behaved more like an activation curve than a thermal one, like a switch being turned on by sunlight. When data first hinted at that behaviour, many dismissed it as coincidence, the result of limited samples. But as days passed and new observations confirmed the pattern, silence fell again. Theories grew tentative. Dr. Drew, in a late-night interview, spoke softly about the green. Maybe it's nothing unusual, he said. Or maybe it's the signature of a process we haven't named yet. Either way, it reminds us that colour is not just beauty. It's physics whispering its story. Meanwhile, the world's space agencies remained publicly mute. NASA's press office released routine updates about rover operations but avoided the subject entirely. The ESA's data portal quietly added a short note, confirming the detection but offering no analysis. The Chinese and Emirati teams, despite active Mars missions, offered nothing at all. That collective restraint only fueled speculation. Were they still processing data? Or had they seen something that required consensus before release? In science, silence can mean many things. Sometimes it's caution, sometimes bureaucracy, and sometimes it's a way to let the data speak slowly, allowing time to transform shock into explanation. Still, for those watching from outside, the silence felt almost theatrical. A global pause, a shared breath before something larger. As 3I Atlas continued its approach, the green glow brightened even further. From Earth's telescopes, it was now visible in short exposures, a small emerald ember against the stars. Spectrographs caught its signature, confirming the presence of CN gas, but still failing to explain the brightness ratio between the gas and the solid body, and so the white heart and green breath persisted, a vision caught first by a lonely rover under a thin Martian sky. Perhaps one day, when data flows freely again, the pattern will make perfect sense. But for now it stands as a quiet contradiction, a shape that should not be so sharp, a light that should not be so green, and a silence that should not be so deep. For 4 long days after Perseverance's sighting, the skies of Mars were quiet, but on Earth, the silence of entire agencies grew deafening. No fresh data from NASA, no images from China's Tianwen-1, which had an ideal line of sight, no commentary from the Emirates Mars mission, whose Hope orbiter was active and healthy. Even the European Space Agency, normally eager to publish, delayed its confirmation until public pressure became impossible to ignore. To most of the world, it seemed an ordinary bureaucratic pause. To astronomers watching 3I Atlas cross the void, it felt deliberate. The first confirmed interstellar object ever seen from another planet had passed within range of at least 7 spacecraft, and not one released its raw imagery. Behind the scenes, a few insiders whispered to journalists that all teams had detected the object clearly, but protocols were slowing dissemination. Those protocols, as one researcher hinted, were not scientific, they were political. You could almost feel the collective hesitation across nations, the weight of deciding how much of an anomaly to admit, how much data to risk misinterpretation. The world had seen what online speculation could do with Oumuamua, transforming cautious physics into sensational claims. No one wanted a repeat. Still, the irony was striking. A fragment from another star had crossed billions of kilometers, only to be met with human reticence once it entered our reach. NASA's official explanation arrived on October 7th. The US government shutdown had begun 2 days before the flyby, and most public affairs staff were furloughed. The rover teams were operating on minimal resources. Press coordination, they said, simply wasn't possible. But outside the United States there were no shutdowns. The European Space Agency, headquartered in Madrid, continued operating normally. China's mission control in Beijing was active. The UAE's Hope mission posted routine telemetry updates. Only on this single topic, 3I Atlas, did every voice fall silent. Such coordination among geopolitical rivals is rare. Yet here, it unfolded seamlessly, as if the silence itself had been rehearsed. Some astronomers defended it. Spacecraft data, they said, required careful calibration before release. A misaligned filter or a misinterpreted pixel could spawn headlines that took months to correct. Others suspected there was more at play. Perhaps the images revealed structures or spectral lines that defied easy classification, and agencies preferred consensus before fueling public imagination. Whatever the motive, the result was the same: absence. The news cycle moved on, leaving a quiet gap where astonishment should have been. In that gap, speculation thrived. Some pointed to the unusual chemistry already reported by ground-based telescopes. If nickel emissions were real and not paired with iron, then 3I Atlas represented something wholly new. Metallic nickel sublimates only at very high temperatures, far beyond what sunlight alone could produce at Mars's distance. For such atoms to appear in a cold interstellar body, some non-thermal process must have been at work. Others focused on trajectory. 3I Atlas had skimmed through a narrow corridor of orbital space, passing close not only to Mars but projected to graze Earth's orbital path weeks later. The odds of that happening by chance were minuscule, roughly 1 in 20,000 according to early models. That precision fueled theories of guidance, though guidance by what remained unspoken. Meanwhile, in quiet observatories in Chile and Hawaii, astronomers continued to collect what little data they could. The Very Large Telescope recorded new spectral lines. The Infrared Telescope facility tracked thermal output. Every night, the comet brightened. The increase followed a pattern steeper than any comet ever observed. A power law of 8. Another of 9. The numbers felt mechanical, as if following an exponential command rather than natural evaporation. Still, science prefers patience. Nature, one physicist wrote, often mimics design when we don't yet understand the pattern. It's a comforting thought, though not always convincing. In time, ESA released a short series of compressed frames from its Cassis camera. The images showed 3 Atlas as a faint, unresolved smudge, its coma discernible, but its nucleus invisible. The agency's official wording was delicate. Outgassing activity consistent with cometary behaviour detected. Chemical composition under analysis. No mention of colour, no comment on shape. The timing of the release was curious, exactly at the moment when public discussion was beginning to fade. By then, Perseverance's photo had circulated widely, degraded by reposts and enhancements, until it became an artifact of its own. The original context, Martian sky, calibrated exposure, stacked processing, was nearly forgotten. All that remained was an impression, a glowing line, a green aura, and an unanswered question. This kind of silence in astronomy often becomes part of the story. It forms a contour around the known, outlining what we are not yet ready to confront. In the 1960s, pulsars were first detected as rhythmic radio signals. The researchers, uncertain of the source, labelled them LGM, little green men, half jokingly, half seriously. They kept their discovery private for months, fearful of ridicule. Eventually, the signals proved to be rotating neutron stars, but that initial caution lingers in scientific culture. Perhaps 3i Atlas demanded a similar pause, a chance to breathe before rewriting the textbooks. In the meantime, Mars itself continued to rotate under its thin, copper-coloured sky. Perseverance, unaware of the global debate its photo had sparked, returned to routine sampling operations. Its robotic arm drilled rock cores, its cameras captured dust devils moving across the crater rim. Above it, the alien sky remained as still as ever, indifferent to human tension. Imagine for a moment standing there beside the rover as mission controllers resume their quiet schedule. The sun dips low, casting long shadows across basalt ridges. The wind carries fine sand like powdered glass. Somewhere high above, beyond the reach of sight, the interstellar visitor continues its arc toward the inner system, unbothered by secrecy, untouched by policy. It will never know that we argued about its colour or questioned its form. It will never know that its passing ignited both awe and caution across an entire planet. It simply moves, ancient and oblivious, as it has for perhaps 1 million years since leaving its home star. And in that thought lies a quiet humility. The universe is full of travellers like this one, crossing interstellar darkness without meaning or malice. We are the ones who give them meaning. We are the ones who decide when silence becomes story. Maybe, someday, those withheld images will surface. Maybe they'll show nothing more than faint specks and blurred pixels, proof that the mystery was ours, not the comet's. Or maybe they'll reveal structure we can't yet explain. Until then, the pause endures, a rare global hush under the vastness of space. By the second week of October, scientists expected NASA to speak, but instead, the agency's website remained static, its feeds silent. The official statement about the government shutdown had already circulated, yet it explained little. NASA missions don't simply go dark. Autonomous systems run themselves. Data flows continue automatically. The rover keeps working, orbiters keep transmitting, deep space antennas keep listening. A shutdown stops the people, not the machines. So, why had data from the most scientifically important visitor in years vanished behind administrative silence? Why too were ESA, China and the UAE all keeping the same quiet rhythm, as if waiting for a cue? In space exploration, coordination between rival powers is rare. Even minor discoveries tend to spark announcements, press releases, public briefings, sometimes quiet competitions over priority. This, however, felt choreographed, as if the agencies had agreed to share not discovery but secrecy. The result was peculiar. The interstellar visitor, 3 Atlas, had just performed a close pass near Mars, the first event of its kind ever witnessed, and yet the story unfolded entirely through unofficial channels. Astronomers traded encrypted emails, amateur skywatchers uploaded faint telescope images to forums. The most advanced spacefaring nations remained publicly mute. NASA's shutdown excuse served as a shield, but observers quickly noted the timing. The shutdown began on October the 1st, 2 days before 3 Atlas's closest approach. It was as though the universe had scheduled its greatest coincidence, and bureaucracy had chosen that same week to close its eyes. Still, a shutdown can't silence the stars. Ground observatories kept watching. The Very Large Telescope in Chile, Keck in Hawaii, and Subaru on Mauna Kea all recorded the object's spectrum. Each confirmed something astonishing. A rapid brightening, inconsistent with normal cometary physics. Nickel emission lines had grown stronger. The coma was expanding in asymmetric plumes, and new wavelengths, cyanogen, faint carbon bands, were rising above the noise. What troubled analysts most was not what they saw, but what they didn't. There was no iron. In most comets, nickel and iron appear together, evaporating from mineral grains in roughly equal proportion. Their atomic structures are bound by similar sublimation thresholds. To find nickel alone, pure, bright, and increasing, was like finding a flame that burns without heat. The silence from official channels now felt heavier. If this object was entirely natural, why hide the confirmation? If it wasn't, why pretend it was ordinary? Among scientists, there's a phrase for moments like this: the corridor of caution. It's that narrow space between revelation and ridicule, where researchers tiptoe carefully, afraid of being wrong for the right reasons. To speak too early risks being labelled sensational. To stay silent risks losing the moment. Even Avi Loeb, who often spoke freely about the possibility of artificial origins, offered only a measured line in an online post. It is too soon to interpret these anomalies. The simplest explanation remains instrumental, though we must remain open to surprise. Open to surprise, it was a phrase both modest and enormous. In the quiet, independent observatories filled the void. One Chilean team released high-resolution spectral data showing that the nickel emission intensity was following a power law slope of 8.43 Ri relative to its distance from the Sun. That number might sound technical, but in comet physics it was unheard of. Normal sublimation, the boiling off of volatile ices, follows a slope of roughly 2 or 3. A slope above 8 implied a chain reaction, a runaway effect not driven by temperature alone. It was as though sunlight wasn't just melting the surface, it was activating something. Meanwhile, cyanogen production was climbing even faster, following a slope of 9.38. The object's spectrum was evolving exponentially, not smoothly. Each night brought a steeper rise. Astronomers began comparing data across hemispheres. Every instrument agreed. 3I Atlas was growing brighter and greener at a rate faster than any comet ever measured. When models were run backward to estimate when the activation began, they pointed to a specific moment, October 4th, the very day Perseverance captured the elongated glow above Mars. The coincidence felt too perfect. Was the brightening a result of the same event the rover photographed? A structural fracture? A surface ignition? Or had it always been glowing that way, only now coming within range of detection? No one knew, but everyone wanted to. The idea that 3i Atlas might have activated above Mars, whatever that meant, spread quietly across the astrophysical community. Some speculated about subsurface pockets of pressurized carbon dioxide suddenly venting. Others imagined nickel-rich ices sublimating in a new kind of phase transition. A few went further, wondering if an engineered mechanism could explain the precision of the response curve. But again, speculation is not science. The true scientist knows that data must breathe before meaning can be assigned. And so, rather than official explanations, the world received only numbers, brightness curves, logarithmic slopes, fragments of spectral data, all trickling through independent observers. It was as if the great machines of exploration, those orbiters circling Mars, had turned their lenses inward, studying our reactions instead of the sky. Perhaps the silence was pragmatic. Perhaps agencies feared public misinterpretation. Or perhaps the truth was mundane, that they simply saw what everyone else saw, a bright green blur, beautiful and strange, yet entirely natural. But the human mind dislikes gaps. Into silence, it pours story. And so, 3i Atlas became not just an astronomical event, but a mirror, a reflection of how our species handles the unknown. We build instruments to seek knowledge, and then, when knowledge surprises us, we hesitate to share it. We wait for confirmation, for permission, for consensus. All the while, the universe keeps moving, unbothered by our pacing. Imagine for a moment looking up from the Martian plain at that precise instant. The sky is cold, almost violet, thin clouds brushing the horizon. Somewhere far above, a white spindle of light crosses silently, shedding a faint emerald glow. It's as if a frozen memory from another world has chosen this one brief moment to reveal itself, and then it's gone. Back on Earth. The debates continue, but Mars returns to its silence. The rover rolls on, its tyre tracks the only marks of life in that crater. Above it, an object from the stars keeps moving inward, following a curve drawn by gravity alone, or perhaps by something more. As weeks passed and 3i Atlas continued its plunge toward the inner solar system, one truth began to solidify. If that elongation above Mars was real, if the white streak wasn't an artifact but the outline of a solid form, then the object's shape was deeply unusual. No natural body of that scale had ever been recorded with such proportions. Even Oumuamua, elongated though it was, measured only a few hundred meters. 3i Atlas was estimated to be nearly 20 kilometers long, about the distance between two city centers, and perhaps 4 or 5 kilometers wide. The scale alone placed it beyond comparison with any known comet or asteroid. Most comets are chaotic snowballs, loosely bound rubble piles that fracture easily. Even minor stresses from solar heating can tear them apart. For 3i Atlas to remain coherent, its tensile strength had to be extraordinary, perhaps metallic, perhaps monolithic. That possibility unsettled researchers more than any optical illusion could. The first to voice it was, again, Avi Loeb. In a restrained blog entry, he noted that if the elongation held true, the object might be rotating slowly along its long axis, maintaining stability much like a baton in zero gravity. He reminded readers that nature occasionally produces elongated forms, the asteroid 1620 Geographos, stretched by repeated impacts, and the fragile contact binary Arakoth at the edge of the Kuiper belt. Yet none approached 3i Atlas's ratio or smooth brightness. The odds, he wrote, are long but not impossible. Others were less cautious. Some speculated that such geometry could result from catastrophic breakup, perhaps a proto-comet torn from its home system, fused by heat and hurled into interstellar night. A few wondered if magnetic fields could have shaped it, pulling molten nickel into a long filament before it cooled. But all these theories faced the same obstacle: time. 3i Atlas was moving too quickly and staying too bright. If its structure were fragile, the stresses of rotation and solar heating should have disintegrated it. Instead, it glowed steadily, maintaining its form as it passed the orbit of Mars and curved sunward. To the patient eye, its motion had an elegance bordering on deliberate. Each new observation refined its trajectory, and the numbers defied randomness. Its inclination, only 5 degrees off the ecliptic, was a rare alignment. The probability of such a shallow tilt for an interstellar body was about 1 in 500. Even more uncanny was its chain of planetary encounters, near Mars first, then projected to pass within viewing range of Earth, and finally to swing close to Venus before escaping again. Each pass within millions of kilometers, each near misprecise to fractions of a degree. Of course, probability is not intent, but intent is the shape our minds give to improbability. Theories multiplied. Some saw a natural traveller captured by the solar system's gravity, tracing an accidental but intricate route. Others whispered of artificial design, of trajectories chosen for observation, perhaps reconnaissance. Both camps shared one truth. 3 Atlas didn't behave like debris, it behaved like something holding itself together. Observational data supported this sense of coherence. Its brightness curve didn't fluctuate as expected from tumbling. There were no sudden flashes from random rotation. Instead, its reflected light pulsed gently, suggesting a slow, rhythmic spin, perhaps 1 revolution every few hours. Such steadiness hinted at either a balanced mass distribution or a smooth surface, unlikely for a fragmented body. At the European Southern Observatory, a team used adaptive optics to analyse polarisation, the way light waves align after bouncing off a surface. The results implied a reflective texture smoother than dust-covered ice, more like polished regolith or fused glass. Still natural perhaps, but exotic, like something formed under conditions foreign to our solar system. As it brightened, 3i Atlas drew inevitable comparisons to Oumuamua, the first interstellar object which had also displayed an unexplained acceleration as it left the Sun, an acceleration not fully accounted for by outgassing. That mystery had sparked years of debate. Now, with 3i Atlas showing an even stranger chemistry, some joked that the cosmos had offered a sequel. But if this was Oumuamua's echo, it was louder, greener and heavier. Estimates placed its mass near 30 billion tons, enough that even the Sun's radiation pressure would barely budge it. And yet, its course wobbled minutely, as though something subtle were adjusting its direction. Perhaps uneven jets, perhaps something we couldn't name. Those who studied its orbit noticed another curiosity. Its incoming vector pointed within 9 degrees of the direction of the 1977 WOW signal. That mysterious radio burst once detected from the constellation Sagittarius. The coincidence meant nothing statistically, but symbolically it was irresistible. 2 unexplained phenomena, 48 years apart, now appeared to share a piece of the sky. Even cautious scientists allowed themselves a smile at that one. For the public, imagination filled the vacuum. Online forums revived every dormant theory about Oumuamua's origins, alien sails, derelict probes, fragments of shattered worlds. But behind the noise, something subtler happened, a quiet resurgence of curiosity. People began pointing backyard telescopes skyward again, tracking a pale smudge through the constellations. It was too faint for the eye, yet it felt near, tangible, as if human attention itself could bridge the gulf. What makes an object mysterious is not only its physics, but its timing. 3 Atlas arrived when the world below was distracted, divided, weary of headlines, and then from across interstellar distances came a thin beam of light, so distant it could have gone unnoticed, so faint it could have been dismissed. Yet it reached us anyway. Perhaps that's the quiet gift of such visitors, to remind us that discovery doesn't always come through grand announcements. Sometimes it arrives as a whisper above another world, a streak of light that says, "You're not finished learning." If the elongation is real, if the shape truly holds, and somewhere between Mars and the Sun travels a shard from another star, long, white and steadfast. It may be rock or ice, or something we've never catalogued, but whatever it is, it carries the geometry of mystery itself, narrow, deliberate, beautiful in its refusal to explain. Tonight, if you step outside and look east before dawn, you won't see it with your eyes. It's too faint, too far, hidden in the haze of sunlight. But it's there, sweeping silently through the inner system, a slender traveller tracing a path older than memory, waiting to vanish again into the dark between stars. By mid-October, the most powerful telescope humanity had ever built, the James Webb Space Telescope, turned its golden mirrors toward 3i Atlas. From 1 million miles away, orbiting the quiet Lagrange point beyond the Moon, Webb opened its infrared eyes and began dissecting the object's light into spectra. Each wavelength became a line of chemistry, a barcode of atoms whispering what they were made of. The results were not what anyone expected. Comets are usually dominated by water. When sunlight warms their surfaces, ice turns to vapour, releasing familiar gases: carbon monoxide, carbon dioxide, methane, ammonia. But Webb saw something alien in the proportions. 87% of the detected emissions were carbon dioxide. Only 4% came from water. The rest were trace hydrocarbons, faint and fleeting. No comet in our solar system shows such an imbalance. Even those formed in the outer Kuiper belt carry at least some frozen water. It's part of the solar recipe. Yet here was a visitor whose chemistry seemed tuned to a different kitchen entirely. Webb's instruments, especially the NIRSpec spectrometer, recorded narrow emission bands that revealed not just the presence of CO2, but its temperature and velocity. The gas wasn't boiling evenly from the surface. It was streaming in focused jets, narrow plumes erupting from discrete points on the body. That pattern too was strange. A natural comet vents chaotically with hundreds of microjets. 3 Atlas appeared disciplined, releasing carbon dioxide along specific repeating directions. Those jets also seemed to curve slightly against sunlight, suggesting some internal geometry was shaping them, perhaps cavities or trenches funneling the gas like exhaust nozzles. It was possible, of course, that this was illusion. But even the cautious analysts at the Space Telescope Science Institute admitted that the data implied localized emission regions inconsistent with a uniform crust. In plain words, something about 3i Atlas was organized. The chemistry itself posed more questions than it answered. Carbon dioxide, when exposed to ultraviolet radiation, can split into carbon monoxide and oxygen atoms. Yet Webb saw no strong oxygen lines. The CO2 seemed stubbornly intact, as if shielded by a surface layer or continuously replenished from deeper reservoirs. And still, there was that green coma. Normally, comets glow green because of diatomic carbon, C2, molecules fluorescing under solar UV. But Webb's spectra showed almost no C2 at all. Instead, it found cyanogen, CN, and traces of nickel vapour, glowing at wavelengths that could blend into green to the human eye. The combination gave 3 Atlas its ghostly colour, a chemical song entirely unlike any local comets. Down on Earth, researchers in Chile and Hawaii cross-checked the data. The Very Large Telescope confirmed the nickel signature and added a puzzle. There was no corresponding iron. In cosmic chemistry, nickel and iron are twins. They condense from supernova ejecta at nearly identical temperatures and almost always appear together. The ratio between them across the galaxy is practically constant. But in 3i Atlas, nickel shone bright while iron was absent, as though the two elements had been separated by design. No natural process known could filter one from the other so cleanly. A few theorists proposed exotic origins. Perhaps 3i Atlas came from the core of a world that once orbited a carbon-rich star, its crust burned away, leaving only a nickel-dominant skeleton. Others suggested the inverse. that it was once the frozen atmosphere of a planet stripped bare, leaving behind metallic condensates. Whatever its story, it came from somewhere with chemistry and temperature regimes profoundly unlike ours. As Webb collected more spectra, the emission shifted. The nickel lines intensified 25-fold over a month, following a mathematical relationship no comet had ever displayed, a power law of 8.43 relative to solar distance. That number became a quiet obsession. A natural sublimation process should double or triple with proximity to the Sun, not rise exponentially. Yet 3I Atlas behaved as if it responded to light not thermally but mechanically, as though photons were triggering a reaction instead of simple heating. One researcher compared the behavior to a catalytic surface becoming active beyond a certain illumination threshold. Another likened it to photochemical ignition, as if sunlight itself was a switch. It was tempting, too tempting, to wonder whether that activation was deliberate. But science avoids the word deliberate. Instead, they said non-thermal or unknown coupling. Perhaps it was coincidence. Perhaps some unfamiliar mineral lattice and nickel-carbon matrix was undergoing a phase change. Or perhaps, as Loeb mused in a soft-spoken interview, we're simply watching physics from a system that obeyed a slightly different history. The data left room for poetry. In meetings at the European Southern Observatory, astrophysicists plotted the evolving spectra like heartbeats. The lines pulsed with the object's approach, each night brighter, sharper, narrower. At this rate, by the time of perihelion, its closest pass to the Sun, it would reach luminosities unseen for an interstellar body. Even Webb, built to study the first galaxies, seemed humbled by it. The observatory had watched light from billions of years ago, yet here it was recording the breath of a visitor only a few tens of millions of kilometers away. A relic of some other dawn crossing paths with our own. If you were to translate those spectra into sound, as some artists do, they would resemble a rising tone, a chord swelling as 3I Atlas neared the Sun, rich in carbon laced with metallic harmonics, a music of chemistry and motion. When the first processed spectra were released, only a handful of scientists saw them. They described the pattern privately as elegant, coherent, like a system responding to itself, words more at home in art than science. But perhaps the difference between those two pursuits is smaller than we think. Because when we stare at something truly new, explanation often arrives later. What comes first is wonder. And so, beneath the velvet silence of space, a white-green wanderer continued its slow brightening, shedding carbon dioxide and nickel vapor in disciplined bursts, following invisible laws that no textbook could yet define. From its home star, wherever that was, to the orbit of Mars and now beyond, it had travelled for untold millennia, and only now, under our brief observation, did it begin to awaken. When the Very Large Telescope's nightly spectra continued rolling in, a single pattern began to dominate every conversation in astrophysics circles: the surge of nickel without iron. At first, the discovery was dismissed as noise. Perhaps the iron lines were buried under overlapping emissions, perhaps calibration errors were skewing results. But repeated observations, cross-checked across instruments in both hemispheres, erased those doubts. Nickel was there in abundance, its spectral lines clean and bright. Iron, however, was missing, vanishingly so. To understand how strange that is, we need to recall how the universe builds metals. In the hearts of stars, fusion binds lighter elements into heavier ones. When those stars explode as supernovae, they scatter the products of their long labour, carbon, silicon, nickel, iron, into space. Nickel and iron are born together, twins from the same fire. Their atomic weights differ slightly, but their cosmic lives are intertwined. They condense side by side into dust grains, form alloys, and melt together in planetary cores. The ratio between them across most of the galaxy is nearly fixed, so when the VLT detected nickel vapor rising from 3I Atlas at such extraordinary intensity, while its twin element remained silent, it was like hearing only one half of a duet. The nickel emission lines were clear at 3414 and 3510 angstroms, glowing steadily even as the object drifted farther from Earth. The rate of emission, measured against its distance from the Sun, followed that steep power law, an exponent of 8.43, meaning its brightness didn't just increase with warmth, it exploded with it. Every night, the data showed the same progression. The nickel line doubled, then quadrupled, then multiplied 25-fold in under a month. In astrophysical terms, it was like watching a whisper become a symphony, and yet no known physical process could account for it. Comets don't generate pure nickel. They liberate small amounts of metal atoms when sunlight vaporizes dust grains, but always as a blend. Even the famous comet Neowise, one of the brightest in living memory, produced nickel and iron together in near equal ratios. 3 Atlas, however, seemed to be selectively freeing nickel atoms, metallic ones, not molecules, without the accompanying debris. It was as though sunlight was striking a surface coated in nickel, heating it to incandescence, but somehow preventing iron from joining the dance. In the early hours of October 12th, the VLT team in Chile shared their latest dataset with colleagues at the Infrared Telescope facility in Hawaii. Both teams ran independent models. Both arrived at the same improbable conclusion. The nickel abundance was at least 10 times higher than in any natural comet ever observed. A quiet tension settled over the research community. Not fear, just awe tinged with disbelief. The kind of pause that happens when equations stop behaving and the universe refuses to play by its usual rules. Some speculated that 3I Atlas's parent star system might have been uniquely rich in nickel, its local chemistry skewed by a rare type of supernova. Perhaps, they said, this visitor was a splinter from a metallic world, a planetary core torn apart and flung into space millions of years ago. Such an object could carry an unusual elemental balance. Others proposed that the nickel wasn't metallic at all, but part of complex compounds formed under alien conditions, breaking apart in ways we'd never modelled. A few, more cautious voices reminded everyone that data is often trickier than its interpreters. Let's not assume miracles, one researcher wrote. We're looking at light through millions of kilometres of solar wind. Filters deceive. But those filters had never produced a deception this consistent, across observatories, instruments, and continents. The pattern held steady, and as it held, imagination bloomed. Theorists began exploring ideas of non-thermal activation, mechanisms that release energy or atoms not through temperature, but through thresholds of radiation or field strength. In laboratory settings on Earth, nickel can release electrons when bombarded with ultraviolet light, a process called photoemission. Could something similar be happening on a cosmic scale? If so, 3I Atlas might not be melting. It might be charging. That word appeared cautiously in one draft report. Anomalous photoactivation of nickel surfaces may account for observed spectral behaviour. It was scientific understatement hiding wonder. Photoactivation meant the object might possess materials capable of transforming light directly into chemical or electrical activity, something closer to a semiconductor than a snowball. By now, the power law curves of nickel and cyanogen production had become icons among astrophysicists. The numbers, 8.43 for nickel, 9.38 for Cn, seemed almost too neat, as though shaped by design. Nature usually paints in broad strokes. This looked drawn by compass. Still, most resisted sensationalism. The term artificial never appeared in official memos. Instead, researchers described unusual chemical kinetics, self-amplifying photoreaction, and anomalous scaling behaviour. In science, language is a form of modesty. You describe the impossible as merely unexpected. Through all this, the object itself continued its silent journey. From the perspective of an observer on Mars, or even one standing on a frozen plateau of Earth, it would appear as a dim emerald smudge against the black, slightly elongated, fading and brightening with each rotation. But in infrared wavelengths, it blazed. The JWST instruments measured a temperature gradient inconsistent with simple sunlight absorption. Parts of its surface were glowing hotter than they should. Others remained dark and cool, as if patches of the object were active while others slept. One late-night report from the Loeb team noted that the emission pattern rotates periodically every 8.2 hours. That rhythm matched the earlier light curve estimates from ground telescopes. A rotation period so precise, so unchanging, suggested internal stability, something holding together under forces that would tear a fragile comet apart. And through all of it, still no iron, still that green glow, still that whisper of order in the chaos. The more data poured in, the clearer it became that 3I Atlas was not simply like other comets. It was rewriting what the word comet meant. To many scientists, it was exhilarating. To others, quietly unsettling. The universe, they realized, was handing them a riddle wrapped in light. And as that riddle drew nearer to the sun, as its nickel heart burned brighter and its color deepened to jade, the silence from the agencies deepened too. Perhaps, one astronomer mused, we had reached the edge of what humanity was prepared to acknowledge about the things that wander between the stars. By late October, 3Z's Atlas had become the brightest interstellar object ever recorded. Still faint to the naked eye, yet radiantly clear through telescopes. Its chemistry was no longer steady. It was accelerating. Nickel production rose sharply, cyanogen emissions steepened, and the object's coma thickened into a luminous shroud. Astronomers began calling it the rising reaction. That phrase felt right, less like a comet outgassing, and more like a chemical process coming alive. In normal comets, the approach to the sun brings a predictable rhythm. Heat drives sublimation, gases vent outward, dust streams follow magnetic fields. But 3I Atlas broke the pattern. Each time it halved its distance from the sun, its brightness didn't just double, it multiplied by almost 20. The power law fit, a steep curve with an exponent of 8.43, was so clean that it startled even the mathematicians. Nature, elegant though it can be, rarely draws lines this straight. What did it mean? No one could say for certain. Some argued it was a runaway chemical feedback, perhaps a nickel-rich surface reacting with solar radiation to release more energy, which then liberated more nickel in a loop. Others thought the shape of the object itself could amplify sunlight, focusing heat onto small regions like curved mirrors. But a few, working late in dim offices surrounded by printouts of spectral graphs, whispered another possibility, that 3I Atlas might not be passive at all. The phrase they used was non-thermal activation. It's a term from materials science, a process in which energy input doesn't simply heat a substance but triggers an internal transformation, like a switch. Catalysts, semiconductors, and some engineered alloys behave that way. They remain inert until exposed to a specific energy threshold, then undergo rapid change without increasing in temperature. If sunlight alone was sufficient to awaken such a reaction, then 3I Atlas could be carrying materials or structures far beyond any naturally formed alloy. One senior astrophysicist at the European Southern Observatory described the behaviour delicately. It's as though something within the object recognises light, not just absorbs it. That statement made its way quietly across the global research community. Not as speculation of life or intelligence, but as awe at the physics itself. Recognition without consciousness, reaction without awareness, yet still something that responded. Meanwhile, the cyanogen, CN gas lines continued their own mysterious rise, following an even steeper curve, 9.38 on the same scale. Cyanogen is rare but not unheard of in comets. Its molecule glows green under ultraviolet radiation, lending many comets their soft emerald hue. But 3I Atlas emitted CN at levels far beyond its apparent mass. It was producing colour faster than it was producing gas, That paradox baffled chemists. Normally, the amount of CN should scale with the surface area exposed to sunlight. Instead, it scaled exponentially, as though invisible layers beneath the surface were suddenly lighting up in sequence. By now, data streams from the James Webb Space Telescope, the Very Large Telescope, and several ground-based observatories were combined into a global model. The best fit predicted that at perihelion, its closest approach to the Sun on October 29th, the object would outshine most comets ever seen, its tail stretching millions of kilometers. But the model also predicted something stranger. The direction of its outflow, the vector of its brightest jets, didn't point directly away from the Sun, as solar pressure would dictate. It pointed slightly forward, toward its direction of motion. That effect, known as an anti-tail, had been observed before, but only rarely. In 3I Atlas, it was extreme. The plume of nickel-rich vapor trailed ahead of the body, as though the emission was being pushed from the rear, propelling it forward rather than backward. It was a comet that seemed, however faintly, to move as if guided by its own exhaust. When models incorporated the anti-tail into orbital simulations, something unexpected happened. The trajectory adjusted itself closer to what telescopes were actually observing. The data fit better when the object was treated not as passive debris, but as something subtly self-accelerating. Of course, no one dared publish those words plainly. The official phrasing became anomalous vector offset consistent with asymmetric outgassing. It meant the same thing, spoken softly. Avi Loeb, when asked, responded with characteristic calm. "It's premature to assume motive from motion," he said. "Nature has its own machinery, often more clever than ours." And yet, the implication was clear enough that he didn't have to say more. The anti-tail, the exponential brightening, the selective nickel emission, all combined into a riddle that physics could describe but not explain. Even the shape of the light curve, the rise and decay of brightness, hinted at deliberate pacing. The increase wasn't random. It followed a rhythm, a symmetrical ascent as though something inside 3I Atlas were awakening layer by layer, just as a machine might come online sequence by sequence. Still, among astronomers there was humility. Every data set contained caveats. Every graph carried uncertainties. The truth might be ordinary, hidden in chemistry we simply hadn't yet encountered. There was no shame in not knowing, only wonder, and so they kept watching. The closer it came to the Sun, the harder it became to observe. The bright glare of daylight, the turbulence of Earth's atmosphere, and the geometry of orbit soon made direct imaging nearly impossible. By October 24th, telescopes worldwide were losing sight of 3I Atlas as it slipped into solar conjunction, a place in the sky too close to the Sun to view safely. But before it vanished, one final dataset arrived. In those last clear spectra, observers noted something breathtaking. The nickel and cyanogen lines began to converge, overlapping into a single composite emission near 388 nanometers, the same wavelength where green light glows most intensely. The colour that had haunted observers from the beginning, the emerald halo first captured by Perseverance, was now peaking, merging two impossible processes into one coherent brightness. It was as though all the chemical voices within 3I Atlas had found harmony. The night the data was processed, an astronomer in Chile wrote a short note to his colleague in Hawaii. "If it's natural, it's the most beautiful reaction I've ever seen, and if it isn't, then it's even more beautiful." No reply was needed. As October waned, the world's telescopes turned reluctantly away. The object would soon be hidden behind the Sun for nearly 2 weeks, unreachable, invisible, alone. The scientists who had tracked it every night felt a strange ache, like saying goodbye to a friend you had never met but somehow understood. They didn't know what it was, only that it was leaving its mark, written in light, on every instrument that had watched it. and that when it re-emerged from behind the sun, everything, its brightness, its shape, its meaning, might change again. The day 3i Atlas disappeared behind the sun, the skies seemed to exhale. For astronomers, there is always a hush when an object slips into solar conjunction, a pause in the music. For weeks they had watched it intensify, transform, and defy expectation. Now, the green light was gone, swallowed by solar glare, unreachable by even the most powerful instruments. But while the sky looked empty, data still whispered from deep space. In the final hours before it vanished, telescopes captured one last burst of activity. Lines of cyanogen that flared sharply, then dimmed, then flared again. Some described it as a pulse, others saw it as a heartbeat. Whatever it was, it faded exactly as the object passed into the sun's blind zone, leaving behind a question that would linger long after. That pulse had marked the peak of a pattern already troubling the community. The comet's coma, its gaseous envelope, was growing greener even as the molecules that normally create that hue, like diatomic carbon, C2, were nearly absent. Something else was making the light. The culprit seemed to be cyanogen, CN, a compound of carbon and nitrogen notorious on Earth for its toxicity, but in space it behaves differently. When bombarded by ultraviolet radiation, cyanogen fluoresces intensely, casting a spectral glow near 388 nanometers, the same narrow band that creates a rich emerald tint. Most comets produce cyanogen as a byproduct of sublimating organics, dark, carbon-rich dust that boils away near the sun. But 3 Atlas showed an anomaly: strong cyanogen lines, weak organic dust. The gas existed without the expected fuel. Spectral models suggested that CN molecules were being created, not merely released. Something on or within the object was manufacturing them. The simplest explanation was chemical recombination. If nickel atoms were being ejected from the surface in great numbers, they could catalyze reactions among existing carbon and nitrogen species, forming cyanogen in situ. Nickel, in high-energy environments, is an efficient catalyst for such processes. That explanation fit the data, until another oddity appeared. The intensity of the CN emission wasn't following the nickel curve exactly. It was ahead of it, peaking slightly earlier, as if the cyanogen was responding to a separate trigger. Perhaps ultraviolet flux, perhaps an internal reaction within the coma itself. In plain terms, the object seemed to glow green before it got hotter. That temporal offset baffled chemists and astronomers alike. It shouldn't be possible. Yet the data, stubborn and patient, kept showing the same timing. A few theorists began to speak in metaphors, not equations. It's like photosynthesis in reverse, one said. Instead of light creating life, light is creating decay, but in a beautiful way. Another called it self-illumination, a process where energy doesn't just reflect but propagates through chemical feedback. The result was a persistent green hue stronger than any natural coma of comparable size. If this had been a comet within our solar system, we might have dismissed it as exotic chemistry, a quirk of molecular ratios, a lucky cascade. But 3i Atlas wasn't from here. Its entire recipe of elements was foreign. Its origin lay in a system that formed under different starlight, different temperatures, perhaps even different fundamental isotope balances. The green became a symbol for that difference. It wasn't just colour, it was identity. In the soft dark between stars, every hue tells a story of birth. Blue light speaks of heat, red of dust. Green is rare. In planetary atmospheres, it hints at life, or at least the precursors of life, molecules that absorb energy and release it through controlled reactions. To see that colour shining from a body so far removed from our solar family stirred old instincts, the same curiosity that once made us search for auroras and phosphorescence in our own skies. But as comforting as the colour looked, its implications were unsettling. If cyanogen was forming spontaneously, catalysed by nickel reactions, then 3 Atlas might be undergoing a kind of surface transformation, a metamorphosis of matter triggered by sunlight, a visitor from another star changing under the touch of ours. Some speculated that the reaction might be altering its structure in real time, converting outer layers into reflective crusts or even reshaping the surface. The periodic brightening seen in earlier light curves might not have been rotation at all, but waves of chemical ignition sweeping across the body. When those theories reached Loeb, he smiled faintly and said only, "We should remember that light can sculpt as well as reveal." Others weren't so poetic. One European researcher noted that the cyanogen outburst fit a mathematical sequence, each spike occurring at nearly perfect geometric intervals, widening slightly each time, like ripples from a stone tossed into still water. It might have been coincidence, or perhaps it was a natural resonance between solar wind fluctuations and the object's rotation. But even coincidence, repeated enough, begins to resemble pattern. And patterns for the human mind are invitations. By now, amateur astronomers across the world were reporting their own sightings. In dark skies of Australia, Chile and southern Europe, observers with large backyard telescopes caught the faint green smear moving slowly through the constellations. Photographs, though grainy, confirmed the same core-to-halo structure, a central white nucleus wrapped in pale emerald haze. Each image echoed that first one from Mars, the shape that had started all this. A long white heart, a green breath. The pattern persisted across distances, cameras, and atmospheres. In online communities, people began to call it the lantern, an object travelling between stars, glowing green in darkness, refusing to conform to what we knew. Scientists didn't adopt the nickname officially, but some admitted that it fit. The green light was not just data, it was presence, steady, strange, quietly alive. As the object slipped closer to the sun, hidden from Earth's view, its light bathed unseen regions of space. Somewhere in that brilliance, reactions we barely understood continued. Nickel atoms ionized. Cyanogen danced in ultraviolet fire. Dust spiraled away in luminous threads, sketching arcs that twisted forward instead of backward. It was in every sense a comet behaving like a contradiction. Hotter, yet colder. Brighter, yet steadier. More active, yet more symmetrical. And as the last clear transmissions came in, astronomers found themselves united not in conclusions but in humility. "We are watching," one report said, "a chemical story that may never repeat. Perhaps, in the unlit depths where it was born, such processes are common. Perhaps every star sends out its lanterns once in a while, carrying traces of forgotten chemistry across the void. Or perhaps this was a singular event, a coincidence of materials, motion and sunlight that will never happen again." Whatever the truth, 3I Atlas had become more than an interstellar object. It had become a reminder of how colour itself can teach us that the universe still has shades we haven't named. In the midst of that eerie green glow, the conversation turned from chemistry to pattern. Patterns, after all, are the quiet fingerprints of nature, or of something else, and 3I Atlas had begun to show far too many. When the data from Webb, the Very Large Telescope, and a half-dozen smaller observatories were cross-compared, the list of anomalies grew into something almost literary, as though each discovery had been a verse in an unfolding poem of improbability. Professor Avi Loeb, now fielding nightly interviews, distilled the puzzle into 7. He called them the 7 anomalies of Atlas. Each, on its own, could have been dismissed. Together, they describe something the cosmos rarely offers: consistency in impossibility. First, its size. At roughly 20 kilometers across, it was too large for an interstellar fragment to have remained intact over eons of cosmic collisions. It should have been shattered long ago by dust impacts or tidal stresses. Second, its shape. That elongated form, 4 times longer than wide, persisted across imaging sources, from Perseverance's faint streak to the parallax data from Earth-based telescopes. Nothing so large, so narrow, and so stable had ever been recorded beyond our solar system. Third, its composition, a surface dominated by carbon dioxide ice, nearly devoid of water. The ratio was an order of magnitude beyond any comet known. It implied formation in a system where water was scarce, perhaps near a dim red star or a world stripped of volatiles by radiation. Fourth, the nickel without iron, the pure metallic vapour rising like breath from stone. It was a fingerprint without a twin, a riddle of chemistry that refused to resolve. Fifth, its trajectory, improbably aligned with both planetary orbits and the ecliptic, tilted only 5 degrees, a precision with a 1 in 500 chance. Sixth, the forward jet, the anti-tail pushing ahead of its motion rather than trailing behind, a paradox of dynamics, as if it were subtly propelled instead of merely eroded. And seventh, its behaviour, the synchronised rise of brightness, nickel and cyanogen, following smooth power laws that mirrored each other like twin signatures. No single anomaly demanded the extraordinary, but together they whispered it. In quiet conferences, some open, some behind closed doors, scientists began to wrestle with the boundaries of interpretation. Could these traits arise naturally? Could coincidence stack itself this neatly, this elegantly? Some said yes. The universe has more imagination than we give it credit for. Others, more cautious, said maybe. And a few, just a few, said no. To those few, the possibility of artificial origin was no longer unthinkable. It was simply uncomfortable. Avi Loeb, aware of his reputation as both pioneer and provocateur, took care to frame his language precisely. Artificial, he reminded everyone, doesn't mean intelligent. It means made, something shaped by process, not randomness. Even crystals are artificial in that sense. Perhaps 3i Atlas was the relic of some forgotten machinery, cosmic debris from a civilization long gone, drifting like a message no one remembers sending. But such thoughts were best spoken softly, preferably at the end of long days, under low lights. For the rest, there were still natural hypotheses to explore. Maybe the shape came from tidal sculpting, a fragment torn from a planet's mantle and refrozen in interstellar cold. Maybe the nickel release was a quirk of metallic frost condensing at specific wavelengths. Maybe the anti-tail was simply the illusion of perspective, created by solar wind interference. And yet, even when strung together, these explanations fit the data like mismatched puzzle pieces, close but never quite flush. Among the 7 anomalies, one captured the public imagination more than the rest: the alignment of its arrival vector. When traced backward across the sky, 3i Atlas's path intersected within 9 degrees of the 1977 WOW signal, that brief 72-second radio burst detected by the Big Ear radio telescope in Ohio nearly half a century earlier. It was a coincidence, of course. The galaxy holds billions of possible directions and overlap is inevitable. But coincidence can be mischievous. The number, 9 degrees, was small enough to stir wonder. It suggested, if not meaning, at least symmetry. A radio signal once shouted from that region of space. Now a silent traveller approached from nearly the same point. The human mind loves mirrors. Reporters latched onto the comparison, though scientists cautioned against drawing lines between unrelated mysteries. It's like seeing 2 ripples on a pond, one astronomer said. They might come from the same stone, or from entirely different ones. The water doesn't care. Still, the idea refused to fade. The 7 anomalies became a shorthand in public discussion, echoed on television, whispered through online forums. The more cautious voices tried to slow the conversation. The universe, they reminded us, is stranger than fiction, but it doesn't owe us narrative. And yet, even within the halls of science, something shifted. Where before the word impossible had served as a wall, it now became a door. Researchers began proposing small missions, intercept concepts using solar sail technology to chase future interstellar objects if they appeared again. Private foundations pledged funding for long-range rapid response probes. For the first time, humanity considered the possibility that the next visitor might not just pass by, but be met. The mystery of 3i Atlas was doing what all great mysteries do, changing behaviour. It was forcing us to imagine faster, act quicker, and believe that chance alignments could hold meaning worth pursuing. Even those who believed it entirely natural admitted that it had accomplished something extraordinary. It had reminded a weary world how it feels to wonder again. In a late-night interview, Loeb's voice carried the calm of a man unbothered by disagreement. "Whatever 3i Atlas turns out to be," he said, "it's already done its work. It made us lift our eyes. It made us remember that the sky is still unsolved." Somewhere on the far side of the sun, that elongated body continued to shimmer, invisible but real, trailing its green breath like a luminous signature across the void. 7 anomalies, 7 questions, 1 enduring silence. Perhaps the answers would come after perihelion, or perhaps they would drift away with the object itself into a darkness that, once again, refused to tell its secrets. By the time October's final week arrived, 3i Atlas had already become legend in the scientific community, a myth born while still under observation. The more telescopes aimed at it, the stranger its story became, and nothing was stranger than its path. Objects that arrive from interstellar space tend to follow random inclinations, coming in at wild angles relative to the planets. But 3i Atlas didn't. It slipped neatly into the plane of the solar system, gliding through the same thin disk where Earth, Mars and Jupiter travel. Its orbit was tilted by just 5 degrees. The odds of that happening naturally? Roughly 1 in 500. That alone might have been dismissed as coincidence. But then the alignments multiplied. First, its pass by Mars, almost exact. Then a projected near cross with Earth's orbital distance, just weeks after perihelion, followed by another close brush with Venus's track. Each event improbably tidy, each within a small fraction of a degree. One simulation from the European Space Agency plotted the geometry in full 3 dimensions, overlaying planetary orbits like concentric rings of glass. 3i Atlas sliced through them as if threading a needle. Natural dynamics are messy. Gravitational interactions nudge, perturb, twist. Yet here was a path smooth and deliberate, as though drawn by invisible compass. Of course, astronomers know that improbable doesn't mean impossible. Randomness sometimes arranges itself into apparent order, but this felt different. Not random, not chaotic, just eerie in its precision. At the Max Planck Institute for Astronomy, a researcher wrote quietly in her log, "If this orbit were a probe, it's the route it would take to study planets without collision." She didn't publish that line. It was personal, poetic, but it captured what many were privately thinking. Still, every serious scientist resisted the temptation to romanticize. Perhaps this was simply a gift of geometry, a cosmic coincidence that allowed the perfect vantage points for observation from multiple worlds. If so, nature had written an elegant script. When orbital analysts backtraced the object's incoming path, they noticed something else, a faint echo of history. Its trajectory intersected the direction of Sagittarius, near the region of sky from which the 1977 "Wow" signal had once flared. The two weren't identical, but they were close enough to share a celestial neighbourhood. The alignment, like so much else about 3i Atlas, was statistically unlikely yet narratively irresistible. The coincidence tugged at imagination. 50 years apart, 2 anomalies, a fleeting radio signal and a silent visitor. both emerging from roughly the same patch of sky. It didn't have to mean anything, but human beings are pattern-seeking creatures. We listen for echoes, even in noise. Astrophysicists reminded journalists that the wow direction was vast, spanning many light years of potential sources. Yet even they felt the poetic symmetry. Space, after all, is more than distance, it's memory. Meanwhile, orbital calculations revealed another layer of improbability. As 3I Atlas approached the Sun, its gravitational deflection would carry it near Earth's path, missing by only tens of millions of kilometres, a wide berth by human measure, but an exquisite near pass on cosmic scales. The timing of that intersection too seemed almost theatrical. Late November, the same window when the object would emerge from behind the Sun and become visible again from Earth. It was as though the universe had staged an encore. Scientists prepared instruments for the reappearance. Observatories in Chile, Spain and South Africa coordinated schedules to catch the first glint when 3 Atlas slipped out of solar glare. The Solar Orbiter mission, stationed between Earth and the Sun, adjusted its detectors to record any activity during perihelion. But before those observations could begin, theorists wrestled with a deeper mystery: why the orbit looked so engineered. Even with natural explanations, gravitational assists from passing stars, or ancient perturbations during ejection, getting such a low inclination and those near misses required a chain of improbabilities stacked neatly atop one another. A 1 in thousands event compounded multiple times, yet improbability isn't proof. Nature sometimes rolls perfect dice. Still, the unease lingered. Avi Loeb once said, "The universe is under no obligation to make sense to us, but when it doesn't, it's usually trying to teach us something." Perhaps this was one of those lessons, one that revealed not design, but our hunger to see it. And yet, if one stood back and viewed the orbital map as art, the pattern was mesmerizing. The line of 3I Atlas curved gracefully through the plane of the planets, touching each orbit like a fingertip grazing ripples on water. It didn't intersect directly, just close enough to stir curiosity, as though sampling rather than striking. One simulation, produced by amateur astronomers and shared online, set the orbits in motion over time. The planets moved like clock hands, while 3I Atlas traced its hyperbolic sweep. At several points, the alignment formed near-symmetric shapes, a 5-pointed pattern drawn by gravity itself. No scientist would read meaning into that geometry, but the sight was haunting nonetheless. Perhaps what unsettled people most wasn't the chance of artificial origin, but the reminder that the universe is capable of elegance without intention. It doesn't need a hand to paint beauty. It simply obeys laws that produce art as a side effect. Still, one couldn't help but feel watched when looking at those orbital plots, an irrational sensation, yet hard to shake. As though the object wasn't just passing through but noticing the worlds it brushed by. For now, it was gone, lost in the sun's glare, unreachable until it re-emerged weeks later. But its path remained printed across simulation screens in every observatory on Earth, a thin silver line arcing through the inner system, threading the orbits of planets that, for a moment in cosmic history, happened to be home to curious observers. Even in absence, it was presence. Even in silence, it was narrative. And somewhere in that balance between randomness and design, between motion and meaning, 3I Atlas continued its graceful fall, wrapped in sunlight and mathematics, bound by no world yet touching all of them in passing. When astronomers finally traced 3I Atlas's path backward through the stars, the line reached into the same region of the sky that had once sent Earth a whisper, the 1977 WOW signal. That famous burst of radio noise had lasted just 72 seconds, captured by a telescope in Ohio and never repeated. It came from the constellation Sagittarius, a quiet patch of sky near the centre of our galaxy, and for nearly half a century it had stood as an unresolved note in the symphony of cosmic mystery. And now, from almost the same direction, came an object gliding through our solar system. Silent, gleaming, green. No one suggested a direct connection. The distances involved were enormous, the timescales incomparable. But coincidences have gravity of their own, and this one drew minds together in quiet fascination. In interviews, Loeb smiled at the question he knew was coming. "We cannot claim relation," he said, "but we can appreciate poetry." The poetry was undeniable. The wow signal, named for the astonished exclamation scribbled by the astronomer who first spotted it, had been humanity's first real brush with the unexplained in radio astronomy. It wasn't noise, it wasn't a satellite, it wasn't anything familiar. It was simply a perfect narrow-band tone from deep space, and then nothing. For decades, it lingered as a question without an answer. Perhaps it was a natural hydrogen mesa, or a reflection from a passing object, or something else entirely. Whatever it was, it came from the direction of Sagittarius, and now, half a century later, from that same region came an interstellar traveller whose behaviour refused to fit expectations. Even the sceptical found comfort in the coincidence. It made the story feel circular, as though the cosmos had a rhythm, a habit of returning to its own mysteries. In late-night forums and quiet observatories, people began to ask, what if the wow signal had been a prelude, and Thrice Atlas was the second verse? Of course, science doesn't thrive on what if. It thrives on what can be measured, and the measurements continued to defy easy interpretation. As the object curved behind the sun, its projected trajectory intersected with regions of deep interplanetary dust, allowing indirect observation through scattered sunlight. Even when unseen, its influence could still be measured. Solar probes like Parker and Solar Orbiter detected faint perturbations in the solar wind. Nothing alarming, just subtle irregularities in the plasma flow near the predicted path. Correlation, not proof. But it added to the feeling that something active was passing through the inner system. By then, global curiosity had escaped containment. The story had crossed from academic journals into the wider world. Political figures began referencing the object during briefings, often with nervous humour. Late-night hosts joked about the green messenger. Newspapers used headlines like "The Stranger from Sagittarius" and "Mars saw it first." For the first time in decades, a celestial event had transcended science to become cultural folklore. Still, within the observatories, the mood remained contemplative rather than sensational. The data was extraordinary enough on its own, no embellishment needed. At the Harvard-Smithsonian Center for Astrophysics, researchers plotted the object's incoming angle against the galactic coordinate grid. It fell within 9 degrees of the WOW signal's source vector. That might sound like a large gap, but in cosmic terms it was razor thin, close enough that both paths could have originated from the same stellar region. That region lies near the galactic plane, rich in older, metal-poor stars, places where planets may form differently, where water and oxygen might be scarce, but metals plentiful. It was perhaps a neighbourhood capable of producing something like Thrice Atlas, dry, dense, metallic, and efficient at holding shape over millennia. If so, the object might be older than Earth itself, flung into the dark before our sun was born. It had travelled across light years of emptiness, and yet its course, by sheer accident or something more, intersected our small world at just the right time for our cameras to be awake. For a moment, humanity felt both impossibly small and impossibly lucky. And perhaps that's why the wow connection mattered, not as evidence, but as story. It reminded us that curiosity is its own kind of continuity. We keep listening, keep watching, keep aligning dots across time, hoping they form a pattern that includes us. In one televised panel, a soft-spoken radio astronomer put it best. Maybe we're not supposed to find messages. Maybe we're supposed to become the kind of species that can hear them when they come. Outside, the October nights grew shorter. the sun moved closer to conjunction with the object, hiding it fully for a week. The world waited in quiet anticipation for its re-emergence, as if watching a curtain close between acts. During that pause, digital artists began reconstructing its path, rendering 3D animations of the orbit, the Mars observation, the green glow, the comparison to Oumuamua. Millions watched them online, lulled by the idea that perhaps, in the vast indifference of space, something had reached out. Not to warn or invade, but simply to pass by and be seen. In a small observatory in Arizona, a graduate student studying the historical data from the WOW signal noticed something coincidental. The original radio burst frequency, when converted to wavelength, corresponded closely to the spectral line of neutral hydrogen, 1,220 MHz. That's often considered a universal calling card, the quiet frequency of the universe itself. And now, 3I Atlas's green glow, 388 nanometers, was the visible light equivalent of a resonance found in carbon-nitrogen chemistry, the signature of cyanogen. Two completely different domains, radio and optical, yet both tied to elemental fingerprints, hydrogen in one, carbon and nitrogen in the other, the building blocks of everything alive. Coincidence, yes, but perhaps not meaningless. Because sometimes meaning isn't a message. It's the harmony between unrelated notes that somehow sound right together. So, as the world waited for 3 Atlas to reappear from behind the sun, people began to listen again, to the hiss of static, the hum of antennas, the deep, breathing silence of space. And for a moment even skeptics allowed themselves the small, humble thought, what if the universe occasionally repeats itself, not to tell us something new, but to remind us that it remembers? By the time the green light vanished behind the sun, the story of 3I Atlas had grown far beyond astronomy. Governments were now being briefed, not because of fear, but because of interest. What had begun as a cosmic curiosity had become a matter of policy. For decades, cosmic phenomena were the realm of scientists and dreamers. But in October 2025, briefings reached political offices in Washington, Brussels and Beijing. Not alarms, updates, awareness. The United States, already entangled in a shutdown, found itself discussing a celestial visitor during congressional hearings. A few members requested classified sessions with NASA and the Department of Defense, citing space situational awareness. What they wanted was simple: assurance that 3I Atlas was not a hazard nor an artifact of foreign technology. Officials reassured them it wasn't. Its mass was enormous but distant, its trajectory safe. Still, the phrasing of those reports, potential non-natural structure unresolved, was enough to send ripples through the press. The White House communications team, careful not to inflame speculation, issued a short statement on October 18th. NASA and partner agencies continue to monitor the interstellar object designated 3I Atlas. No risk to Earth or its orbiting assets is present. Further updates will follow after solar conjunction. That phrasing, after solar conjunction, was like an intermission curtain. It promised that when the object emerged again, something more might be said. Across the Atlantic, the European Space Agency convened its own private roundtable. Attending were planetary scientists, orbital engineers, and a handful of philosophers, a reflection of how wide the implications had become. ESA's Director General spoke quietly of the importance of managing public imagination. In Beijing, the China National Space Administration mirrored the same tone. Their public statement focused on the physics, not the poetry. 3I Atlas offers valuable insight into interstellar chemistry and orbital dynamics. Behind closed doors, however, their analysts were dissecting a different issue: the probability that such an object could align so precisely with planetary orbits by chance. Their calculations matched Western estimates, less than 1 in 20,000. It was not proof of anything intentional, but it was rare enough to keep everyone listening. At the United Nations Office for Outer Space Affairs, a low-key working group drafted contingency language in case the object's behaviour changed dramatically at perihelion. The language was bureaucratic but historic, guidelines for communication in the event of novel or non-natural characteristics observed in interstellar bodies. It wasn't a disclosure policy, it was simply preparation. Yet even that act spoke volumes. Humanity, for the first time, was writing a plan for what to do if the unknown ever looked back. Outside government, the mood was subtler. Science communicators walked a fine line between wonder and restraint. Public fascination was already climbing, driven by social media edits of Perseverance's image and AI-enhanced videos claiming to show a rotating green spindle near Mars. Most were fabricated, but they carried an emotional truth: the need to see what was otherwise invisible. Astronomers tried to cool the fire with facts. They reminded everyone that interstellar objects are, at their core, natural phenomena, frozen archives of other suns. The extraordinary, one scientist wrote, isn't always unnatural. Sometimes it's just rarely observed. Yet even they admitted that 3i Atlas blurred the border between science and myth. A quiet term began circulating in observatories and think tanks: national interest object. It didn't mean weapon or artifact. It meant something that required coordination across agencies, disciplines, and nations. Something too big to belong to one institution. That phrase changed everything. For the first time since Apollo, rival powers began sharing data without hesitation. The US, China, ESA, and the UAE exchanged telemetry in real time through encrypted channels. For a brief moment, humanity behaved like one observatory. The sky, after all, didn't recognize borders. Meanwhile, amateur astronomers, the independent chorus of science, kept the watch alive. They didn't have classified feeds, but they had clear skies. From mountaintops and desert plains, they continued tracking the faint emerald smudge, estimating brightness by hand when machines couldn't. Their reports often reached professionals faster than official channels. It was as though the world had built overnight a distributed telescope made of hope. For many, the experience felt healing. After years of division and noise, there was something serene about uniting around a mystery that couldn't be owned. 3i Atlas became a cosmic equalizer, too far to conquer, too neutral to politicize, too beautiful to ignore. Still, the questions reached high places. Behind conference doors, politicians asked their scientists, if it were artificial, what would that mean? And every time the scientists answered the same way: it would mean we're not alone in creation, but we are alone in interpretation. That phrasing became the quiet mantra of the season. Not alone in creation, alone in interpretation. It echoed across interviews, classrooms, late-night shows. Humanity was realizing that even if 3i Atlas was nothing but rock and ice, the act of wondering, of reading meaning into the dark, was what made us human. By October 26th, the object's predicted perihelion was only 3 days away. Telescopes waited for the sun to move slightly, for the glare to ease. Around the world, observatories prepared for the moment when the interstellar traveller would reappear, hotter, brighter, perhaps transformed. Politicians stepped back, scientists leaned forward, and somewhere in the quiet between, millions of ordinary people tilted their faces toward the night sky. They couldn't see the object, but they could feel it, the shared stillness of curiosity. Across languages and continents, one idea took hold, that maybe this wasn't about discovery at all, but about perspective. The stars had always been there, but for the first time in years, the world was looking up together. While the world's agencies debated and prepared, another movement was taking shape, quiet, patient, and remarkably human. The amateur astronomers, those scattered watchers under dark skies, became the beating heart of the story. They had no budgets, no classified instruments, only long patience and a love for the night. Yet what they lacked in resources, they made up for in devotion. With 3i Atlas hidden from professional view behind the sun, they turned to archival data, stacking images, measuring angles and sharing every faint glimmer they could find. In observatories built in garages and on mountain plateaus, images began to emerge, small, grainy, but beautiful. Each showed the same ghostly pattern, a central white glow, narrow and elongated, surrounded by a faint green halo. Some claimed to see structure within the core, subtle dark bands, geometric hints that flickered across long exposures. Others said it was just artifact, the tricks of optics stretched to their limit. But among the enthusiasts, disagreement was not division, it was joy. They debated gently, annotated one another's work and built online mosaics of images that, when combined, gave a nearly continuous portrait of the visitor's motion through the stars. They called their global project the Atlas of Atlas. In Chile's Atacama Desert, a retired engineer named Miguel used a modest 12-inch reflector and a spectrometer assembled from spare parts. His data confirmed faint emission lines for cyanogen. In rural Japan, an astronomy club captured short exposure frames that revealed a soft, forward plume, the anti-tail curving slightly ahead of motion. In the American Midwest, a high school science teacher guided students to take stacked images over several nights, teaching them how to reduce cosmic noise. Their result matched the professionals, a slim, luminous spindle glowing a gentle jade. These images, though low in resolution, mattered deeply. They provided continuity during the weeks when space agencies went silent. The public could still see something. The mystery stayed alive. Each new post carried the same humility. Data uncertain, but beauty certain. Meanwhile, on the scientific side, the contrast between official silence and grassroots curiosity became symbolic. For once, the world's most important cosmic observation wasn't owned by billion-dollar instruments. It was being chronicled by ordinary hands. People whose backyards had become observatories. The result was strangely democratic. 3i Atlas belonged to everyone now. News networks occasionally highlighted the best amateur captures, but the images themselves did the real work. Their quiet grain, their imperfect detail made the story feel tangible. To see those photographs, faint streaks of light against black, was to remember that the universe doesn't demand perfection to reveal itself. One night, as October drifted toward its end, a collaboration of amateurs across 3 continents aligned their telescopes to record the same section of sky. The plan was simple. Each would take overlapping images for precisely 15 minutes at slightly offset angles to produce a combined exposure long enough to tease out fine details. When they stitched the frames together the next day, what appeared was both astonishing and delicate. The core wasn't just a blur, it had contours. The inner glow seemed slightly rectangular, not circular. It could still be coincidence, the artifact of alignment and camera sensors, but the symmetry was undeniable. The image circulated quietly among professionals before reaching the public. No one made claims, no one declared discovery. The caption was simple: composite from 13 locations, October the 26th, 2025. And yet, for many who saw it, something shifted. It was no longer an abstraction, not a number or a graph. It was an object, solid, luminous, turning slowly somewhere between Mars and the Sun. Astronomy, at its core, is an act of patience. You collect photons that left their source years, centuries, or millennia ago, and you trust that light still carries truth. The amateurs understood this better than anyone. For them, every faint pixel felt like a conversation across time. In online chats, they spoke less of alien possibilities and more of reverence. Whatever it is, one wrote, it's the most patient traveller in history. Another replied, and we're the lucky ones who happened to look up when it passed. Across continents, a shared quiet took hold, a sense that this was more than data, it was presence. As October 29th approached, the date of perihelion, when 3i Atlas would pass closest to the Sun, the amateurs prepared for their final coordinated observation. They knew it would be dangerous to capture. The glare of the Sun could burn their cameras, but they couldn't resist trying. For some, this would be their last chance before the visitor faded forever. And so, on the morning of the 29th, dozens of small telescopes turned toward the dawn horizon. The sky was still pale, the Sun a few degrees below. The observers took brief, careful exposures, shielding lenses, calibrating against twilight. Later that day, when they processed the frames, a handful showed it. A faint, curved streak of light just above the horizon, sharper than before, almost knife-thin. It wasn't bright, but it was distinct. The final glimpse before 3i Atlas vanished into sunlight. They posted the image without embellishment, just a line of text, seen and gone. For professionals, that single photograph confirmed the predictions, its position, brightness and rotation exactly where expected. For everyone else, it was something quieter. Closure, without finality. The amateurs had captured the last heartbeat before disappearance. In the weeks to come, the major observatories would take over again. Data would pour in, filtered through professional caution. But history would remember that for a few brief nights, humanity's clearest eyes were not in space but on Earth, operated by people who looked up simply because they couldn't help themselves. And maybe, in some distant way, that was the object's purpose all along, not to be solved, but to be seen. When the last amateur image faded from the world's feeds, the wait began. October 29th, the day of perihelion, was circled on every calendar in astronomy. That was the moment 3i Atlas would pass closest to the Sun, the moment when its secrets, if any, might be revealed. Yet ironically, it was also the one time no one could see it. At perihelion, the object was hidden behind the Sun's brilliance, unreachable to telescopes on Earth. All that humanity could do was listen, record, and hope that its instruments orbiting near the inner system were watching. In the hours leading up to that invisible moment, there was an odd global hush, part anticipation, part fatigue. It felt less like the climax of a discovery, and more like a deep breath before an eclipse. The European Space Agency's solar orbiter, positioned closer to the Sun than Earth, was the only craft perfectly placed to observe. Its cameras were not designed for deep space imaging. They studied solar flares and plasma arcs, but engineers had improvised new exposure settings just for this object. The solar orbiter's team remained quiet. No leaks, no updates. Only one line appeared on the mission log on October 30th. High sensitivity mode engaged, perihelion window complete, data under review. The world waited. For 4 days nothing came. Then a rumour surfaced, somewhere inside the ESA network. Data packets from the solar orbiter were encrypted and flagged as priority anomaly. That phrase, bland as it sounded, carried weight. In the language of agencies, anomaly can mean anything. Sensor noise, processing glitch, or something unexplainable. But priority anomaly meant it wasn't dismissed. No official word followed, and so the silence grew thicker. The last time a mystery this large had been met with such restraint was decades ago, when the first neutrino detections puzzled physicists. Back then too, data had trickled in slower than questions could form. But this felt different. There was an undercurrent of deliberation, as though too many eyes were watching, and the agencies knew it. Across the world, observers stared at coronagraph images of the Sun, hoping to catch a faint thread of motion, the glint of something crossing behind that vast fire. None appeared. The coronagraphs were blinded by brightness. It was as though the interstellar visitor had simply dissolved into light. In Chile, an astronomer named Rosa Alvarez stood outside her observatory long after her instruments had shut down, watching dawn creep across the desert. She said later that she felt a strange quiet that night, as if the sky itself had exhaled. It was like a pause between verses, she told a colleague. Something had ended or maybe just turned the page. That sentiment spread. After weeks of breathless fascination, the silence became its own story. What do you do when a mystery refuses to reveal itself? You wait. And in that waiting, people began to notice the poetry of the situation. For 4 days, nothing. No images, no signals, no new data. It was as though the universe had drawn a curtain, giving us time to absorb what had already been seen. Then, quietly, on November the 2nd, the European Space Agency released a single press note, short, factual, devoid of flourish. Preliminary analysis of solar orbiter observations indicates detection of 3I Atlas during perihelion passage. The object exhibited transient luminosity fluctuations within the inner corona region, duration approximately 12 minutes, subsequent tracking unavailable, data verification ongoing. 12 minutes, that was all. Reporters seized on the phrase, transient luminosity fluctuations. It was too vague to interpret, too cautious to clarify. Did the object flare, fragment, reflect sunlight in some structured way? The agency wouldn't say. Avi Loeb, when asked, offered a kind of verbal shrug. It brightened briefly, he said. That could mean many things. A rotation, a breakup, or a new form of activity. But until we see the raw data, all we can do is imagine. And imagine people did. Some saw the 12-minute flare as the end, a natural disintegration under solar stress. Others said it could mark a phase transition, the moment when volatile materials burned away, leaving a metallic remnant. A few, the romantics, the dreamers, whispered that perhaps it had activated. But in truth, no one knew. The brightness curve was incomplete, the data still encrypted, the agencies still cautious. Meanwhile, the Parker Solar Probe, much closer to the Sun, was also recording plasma conditions during that same window. Weeks later, when those logs were made public, analysts noticed an odd pattern, a brief local magnetic disturbance, far smaller than a coronal mass ejection, but centered exactly along the projected path of 3I Atlas. It was fleeting, like a brush of static in the sun's breath, too faint to be dangerous, too clean to be coincidence. The disturbance suggested that the object hadn't disintegrated entirely. Something had passed through, alive or inert, interacting with the solar wind in a way that produced coherence instead of chaos. A ripple, not a blast. Perhaps it had survived. After perihelion, the object would be moving outward again, slipping back into visibility from Earth's side of the Sun. Observatories prepared to catch its reappearance in mid-November. If it emerged intact, the coming weeks would show whether it had changed. Shape, brightness, chemistry. Until then, the world waited under its quietest sky in years. It was a strange kind of silence, not the silence of absence, but of anticipation. Like standing on a beach at dusk after a wave has retreated, knowing another is coming. No one could yet say whether 3I Atlas had survived its plunge toward the Sun or been vaporized in brilliance, but one thing was certain. Its passing had already rewritten the rhythm of curiosity itself. Scientists spoke more gently, politicians asked more carefully, and millions of ordinary people looked up every night, not expecting answers, but feeling, perhaps for the first time in years, that they were part of something vast and unsolved. Maybe that was the gift of the interstellar traveller. Not revelation, but renewal. For the first time in decades, humanity had turned its collective gaze not toward screens or wars, but toward the same distant point in the sky, waiting for a single faint speck of green to return from behind the sun. The first night 3I Atlas was expected to emerge again, November 10th, 2025. The world's observatories pointed their mirrors to the eastern sky before dawn. The object would be faint, hidden in twilight, still close to the sun, but its reappearance would confirm whether it had survived. Across mountaintops, deserts, and quiet valleys, instruments waited in synchronized silence. For hours there was nothing. The sky brightened, data streams stayed flat, and then, just before dawn in Chile, the signal arrived. A faint streak on the detector of the very large telescope, precisely where the trajectory predicted it should be, but dimmer, much dimmer. The green halo was gone. What remained was a soft, pearly white point of light. Its brightness had fallen nearly 80% since before perihelion. Its colour curve flattened. The cyanogen lines had vanished. 3 Atlas was still there, but quieter. For a moment, that stillness felt anticlimactic. After all the speculation, all the build-up, the interstellar visitor had survived the sun only to emerge faded, subdued, almost ghost-like. But for astronomers, that faint return was miraculous. Surviving a close solar pass intact was improbable enough. Doing so while travelling at interstellar speed was astonishing. They began gathering spectra immediately. The first readings came within hours. The results were unexpected again, though not in the way anyone imagined. The nickel lines, which had blazed before, were gone. So were the cyanogen bands. The object's entire emission profile had shifted. Instead of bright metal vapour, the spectrum now showed only weak carbon dioxide absorption. No sign of active outgassing. In other words, 3I Atlas had gone dormant. It had shut down. If it were a comet, that meant it was exhausted, its volatile material spent. But the curve didn't quite match an inert rock either. Its albedo, its reflectivity, had changed, becoming unusually uniform across wavelengths, as if its surface had fused into a single continuous crust. Some described it as vitrification, the transformation of matter into glass. Others proposed sintering, where extreme heat welds particles together. Whatever the mechanism, it left the object looking smooth, dense, and oddly symmetrical. When high-resolution images arrived from the VLT and Keck telescopes, they revealed something remarkable. A faint linear glint along one edge, like a reflection from a curved plane. Even under grainy conditions, the shape appeared more refined than before, as if the chaotic coma had collapsed into form. In its silence, 3I Atlas had become more geometric. That was the phrase used in one internal memo. Post-perihelion geometry exhibits anomalous regularity. It was written carefully, but the implication was clear. Whatever had happened near the sun, burning, melting, or metamorphosis, had left the interstellar traveller cleaner, smoother, less natural looking. And then came the most surprising data of all. The object's brightness curve showed a subtle oscillation, a periodic flicker every 8.2 hours, the same period identified before perihelion. But now the amplitude of that flicker had increased, as though the rotation was accentuating some reflective feature. It wasn't emitting, it was reflecting, in pulses. Some said it was just a rotation effect, the glint of a long body turning end over end. Others noted that the intervals were almost too regular. 8.2 hours, precise to within a few seconds, repeating with clock-like accuracy over multiple days. A tumbling rock should wobble. This didn't. In the world's observatories, researchers sat quietly over coffee staring at the graphs. One of them said, "If that signal came from a transmitter instead of a telescope, we'd call it engineered." Another replied softly, "Maybe it doesn't matter what we call it." The rhythm itself, steady, elegant, constant, felt like a language of motion. Not intentional, perhaps, but deliberate in effect. For the next week, every major telescope continued to track the object as it receded from the sun. It brightened slightly, then levelled off, settling into a serene stability. No outbursts, no jets. Just a faint glimmer spinning slowly in the darkness between orbits. Spectroscopic data showed its surface cooling, radiating heat gradually like tempered metal. Its trajectory, slightly altered by solar gravity, now aimed it outward toward the asteroid belt. Within months, it would cross Jupiter's orbit and then vanish into interstellar night again, perhaps forever. As the data stabilized, so did public attention. The world's fascination softened into reflection. For some, 3i Atlas had been a disappointment, a mystery that refused to climax. For others, it was perfect that way. It had appeared, awakened, transformed, and then, as if aware of the gaze upon it, chosen silence once more. In laboratories and lecture halls, scientists debated whether it was truly dormant or simply in a new phase. Could it reactivate when far from the sun? Would the nickel lines return, faint but familiar? Would it glow again when it passed another star centuries from now? No one knew. But one phrase began to appear again and again in papers and interviews. Moment of truth. That had been the phrase whispered before perihelion, the time when the object's nature would finally be revealed. Now, in retrospect, the truth seemed to be that the moment never came, or perhaps that it came and went, quietly, in those 12 minutes of unexplained light near the sun. We may never know what happened in that brightness. Maybe 3i Atlas simply sublimated its last volatile layers, becoming inert. Maybe it crystallized, sealing itself for another voyage through the void. Maybe it changed state entirely, no longer matter as we understand it. Somewhere, in the vast space between Mars and Jupiter, the traveller drifted on, cooled and calm, unhurried as ever. It reflected sunlight in its measured spin, steady as a heartbeat, silent as a thought. And here, back on its brief world of origin and politics and wonder, humanity went on arguing, dreaming and imagining what it all might mean, because that perhaps was the final gift of the visitor. It left us with a rhythm, a pulse of curiosity repeating every 8 hours, echoing through our thoughts like a faint signal reminding us to look up. By late November, the data was complete. 3i Atlas had survived its solar encounter, quiet and intact, fading as it drifted outward through the inner system. Its brightness continued to decline, its colour stayed neutral, its emissions had ceased. No further outgassing, no nickel or cyanogen lines, only a faint metallic shimmer that followed the sun like a ghost of light. It was, in a sense, finished, and yet its silence said more than all its earlier activity. At the European Southern Observatory, the final photometric sequences were compared with those from before perihelion. The numbers told a simple story. The object had lost over 90% of its mass in volatile material, but its core remained intact, monolithic, unfractured, still following the predicted outbound trajectory. That trajectory, projected forward, showed a gentle bend from the sun's pull and then a slow escape back into the darkness between stars. It would pass the orbit of Jupiter in the early 2026, then drift outward through the Kuiper belt by 2030. Beyond that, it would vanish from our telescopes forever. The object's residual reflectivity, however, continued to puzzle analysts. Its light curve was too smooth. There were no sharp dips, no random fluctuations from surface irregularities. For something that had been bombarded by the sun's heat, its consistency was uncanny. When the final composite images were enhanced, the silhouette emerged clearly for the first time. A long, tapering body with symmetrical ends, narrower at the tips than the centre, like a spindle or a slow-turning shard of obsidian. It wasn't a perfect cylinder, nature rarely is, but it was more regular than any comet core ever documented. The astronomers didn't rush to interpret, they simply described. Shape, elongated. Rotation, stable. Surface, reflective, vitrified, uniform. And then, a final note that few outside the field ever read. The post-perihelion surface scattering model implies high-density material with dielectric properties inconsistent with porous rock or ice, possible metallic glass composite. It was the last scientific sentence ever formally published about 3I Atlas. After that, the world moved on. The news cycle turned to other things: elections, storms, discoveries closer to home. The public's fascination faded as quietly as the object itself. But among the small circle of astronomers who had lived with it day and night, something lingered. In late November, Loeb published a brief essay, not a paper, but a reflection. He wrote, "It is possible that we have just witnessed the most natural of all miracles, matter remembering the shape of thought. Whether 3I Atlas was born of randomness or reason, it reminds us that curiosity is the universe becoming aware of itself." The essay spread quietly, quoted in classrooms, whispered in documentaries, read aloud in planetariums under domes of artificial starlight. It didn't solve the mystery. It simply gave it grace. Meanwhile, NASA's Mars team finally released the full-resolution image from Perseverance's navcam, the one that had started everything. It showed the same streak above the Martian sky, an elongated, glowing band, thin and bright at its centre, green-edged at the margins. When enhanced, it revealed fine structure in the light, as though two layers overlapped, one solid, one gaseous, both moving in harmony. Looking back, the photo felt timeless. A single frame of an alien object seen by a robot on another world, an image that had briefly united a species under one question: what are we looking at? The question would never be answered fully. But maybe that was the point. Some mysteries are not puzzles to be solved, but mirrors to be noticed. In early December, the last signals of 3I Atlas drifted beyond range. The object dimmed below detectability. The final observation came from an amateur telescope in Namibia, which recorded one last pixel of light against a field of faint stars before it vanished completely into the black. And then, nothing. For a moment, the universe felt emptier for its absence. But only for a moment. Because the sky has a way of filling its own silence. In the months that followed, astronomers turned back to their other tasks: exoplanets, dark matter, distant galaxies. Yet every so often, during long nights at the console, someone would glance at the coordinates where 3I Atlas had been and feel a small pulse of wonder. Somewhere out there, that slender shard of green-white light was still moving, spinning slowly through interstellar cold, carrying the memory of one brief encounter with a small, curious civilization. And perhaps, far in the future, when it passes another star, another set of eyes will catch it in their own sky, and they too will ask what we once asked. Was it alive? Was it built? Or was it simply the universe practicing geometry again? The truth may never matter. What mattered was that, for a few luminous weeks, humanity remembered how to wonder together. We may never know what 3I Atlas truly was, but every quiet night that we look up, we are, in some way, continuing its journey, turning slowly under starlight, reflecting what little brightness we have, unhurried, unending. So now, as the object fades beyond our reach, we return to stillness. The stars remain, scattered across the dome of night, their light older than our species, older than our doubts. The mystery of 3I Atlas has not been solved, and perhaps it never will be. But its silence leaves something behind, a kind of calm. Maybe that's what all cosmic stories are meant to do. They begin with curiosity, rise into wonder, and end in quiet acceptance. We don't always need conclusions. Sometimes, it's enough to have witnessed the passing of something ancient through the small window of our moment. Imagine it now, far beyond Mars, drifting toward the outer dark. Its surface cool, its motion steady, its purpose, if it ever had one, fulfilled. Around it the faint sunlight grows weaker until even reflection fails, and it becomes invisible again, one more shadow among billions. And here we are, beneath our thin atmosphere, still turning, still breathing, still watching. The same light that once struck its surface now falls softly on oceans, on rooftops, on your hands. The same photons that touched that traveller now warm this world. That's the quiet thread that binds us all, the unbroken exchange of light. So take one last breath with the cosmos tonight. Let the air move slowly. Let the sound of the world fade. Somewhere out there, a green ember drifts into forever. And somewhere in here, in the hush behind your thoughts, wonder continues to glow. Sleep well, traveller of Earth. The universe is wide, but for now, it's enough just to dream beneath it.